Good afternoon. Okay. 1 to 9 timings. I'll see maximum today we'll close this chapter and root locus volume 1 problems we'll try to solve. We'll complete root locus volume 1 problems today. In the schedule written 1 to 9 na, I asked that fellow. I asked him, sir, we'll see you 1 to 7. Okay, we'll see. Okay. Now it is showing 1 to 6. No 6, 1 to 7, 1 to 7. Right. Whatever it is. We'll see. Okay. 1 to 7 now, 1 to, we'll see. Whatever that. We will complete the chapter first. After that, we'll decide. Okay. Right. Note on the problem. So last day, we solved one problem. Remember, na? Last day, one problem we solved. Just drawing the border plot. So I'll write the transfer function because it required. Next one problem I'll solve. Just quickly I'll write the transfer function what we solved. 10 by s into 1 plus s by 0.2 whole square 1 plus s by 2 whole cube 1 plus s by 10 whole power. For next problem we required this. I thought of drawing before itself. I forget. 1 plus s by 50 whole power 6. 1 plus s by 100 whole power 7. 1 plus s by 200 whole power 8. 1 plus s by 500 whole power 9. 1 plus s by 600 whole power 10. 1 plus s by 1k. Now draw the diagram. Diagram also already I drawn. But for explanation required, I'll draw with superfast. So this is 0.01, I think. 2.2. 1 minute, I'll complete this. 0.2, 2, 10, 20, 50, 100, 200. 1 minute, it will complete. Right. This is minus 20. Minus 20 minus 40 plus 40 minus 40 correct na? Minus 20 plus 40 minus 60. minus 60 at 2. Change in slope. Minus 20 plus 40 minus 40 kada at 0.2 at 2 at 1 minus 20 minus 20 ikkada plus 40 so plus 20. So it did everything wrong. So here okay, minus 20 plus 40 plus 40 means plus 20 plus 20 minus 60 minus 40 minus 40 plus 40 plus 40 next at 20 minus 60 I think again plus 60 plus 60 next ikkada minus 80 I think plus 80 minus at 500 100 I think plus 100 minus 300. Note on next problem. Is it correct? Note on the problem. Okay. Right. Note on the problem. Write it. Find the note on the problem. Find the change in slopes. Find the change in slopes at the following corner frequencies. Find the change in slopes at the following corner frequencies. First one, omega equal to 2 radians per second. Second one, omega equal to 10 radians per second. Omega equal to 2, 10, 20 radians per second. Fourth one, omega equal to 50 radians per second. Fifth one, 100 radians per second. 200 radians per second. 500 radians per second. 600 radians per second. 1K radians per second. Find the change in slope at the following corner frequencies. This is the first bit. Second bit. Second bit is find the slope of the line between two corner frequencies. Find the slope of the line between two corner frequencies. Find the slope of the line between two corner frequencies. Between two corner frequencies. First one, 2 to 10 radians per second. Second one, 20 to 50 radians per second. Third one, 200 to 500 radians per second. Fourth one, at high frequency, at high frequency, at high frequency. Or we can say very high frequency, high frequency. Very high frequency means infinite. High frequency means infinite. Yeah. Third bit. Find the slopes around the following corner frequency. Around the following A. First one is 2. Second one is 20. $200. For G of S, H of S equal to S power 5, 1 plus S by 2, whole power 10, 1 plus S by 10, whole power 20, 1 plus S by 20, whole power 30, 1 plus S by 50, whole power 40, 1 plus S by 100, 1 plus S by 200, whole power 60, 1 plus S by 500, whole power 70, 1 plus S by 600, whole power 80, 1 plus S by 1k, whole power 100. Come on, solve it. Come on, Bhaiya, come on. Come on, solve it. How to find the change in slope at corner frequencies? Change in slope you have to find. How to find change in slope? Come on. Listen. Listen, Bhaiya. Change in slope is nothing but slope of number of finite poles, finite zeros at that corner frequency. Listen, all of you. For example, I want change in slope at 10. For example, I want change in slope at 10. Change in slope at 10. We want change in slope at 10. We want at 10. What is the formula for change in slope? Change in slope. Change in slope equal to new slope minus old slope. Change in slope equal to new slope minus old slope. New slope minus old slope. Change in slope equal to new slope minus old slope. New slope minus old slope. So what is the new slope? What is the old slope? Before corner frequency, whatever the slope is there, that is called new slope. After the corner frequency, whatever is there, that is called old slope. Before corner frequency, new slope. After the corner frequency, old slope. After the corner frequency, old slope. New slope minus old slope. Before corner frequency is called new slope. after the corner frequency called old slope. Now tell what is change in slope. Simply it is called CS. So what is change in slope? Tell new slope is I written wrong na. Before the corner frequency is called the what? 1 minute. Before corner frequency is called old slope. After the corner frequency is called new slope. After new. Before means old. Before the corner frequency is called the what? Old slope. After the corner frequency called new slope. Now tell what is the change in slope. New slope is plus 40. Minus of old slope. What is the old slope? Minus of minus 40. How much you are getting? Plus 80. Plus 80. Change in slope equal to plus 80. Plus 80 means what? What is the meaning? Plus 80. Sir, one more thing. For example, I want change in slope at 500, for example. I want change in slope at 500. Bolo, what is the change in slope? Tell. New slope. What is the new slope? Tell. What is the new slope? Anybody? Come on. New slope is minus 100. Of old slope. What is the old slope? Tell. Plus 80. How much you are getting? Minus 180. Why you got minus 180? Why you got minus 180? Minus sign indicates poles. Minus sign indicates poles. 180 means how many poles? Divided by 20 you do it, because each pole 20 na, divided by 20 means 9 poles. There should be 9 poles at where? 500. There should be 9 poles at 500. Check it. At 500 how many poles? 9 poles. At 500 9 poles. That's why we got it minus 180. Why you got plus 80? Plus indicates zeros. Plus indicates zeros. Plus indicates the zeros. Divided by 20, do it. 4. There should be 4 zeros at where? There should be 4 zeros at where? 10. This is calculated at 10. Na? There should be 4 zeros at 10. Check it. At 10, how many zeros? 4 zeros. At 10, there are 4 zeros. At 10, there are 4 zeros. That's all. There are 4 zeros at 10. That's all. Okay, na? So, there are 4 zeros at 10. So, simply change in slope is nothing but slope of number of finite poles, finite zeros at that particular corner frequency. Change in slope is nothing but slope of number of finite poles, finite zeros at that particular corner frequency. Okay, come on. So write its statement. What is the statement? So why I taken this problem means, because here diagram drawn. I will explain. I give the explanation for this. You write the answer for that. So here plus 80, got it. Plus 80 means what? 4 zeros. 4 zeros exist in the transfer function. No need to calculate like this. In the exam, they don't give this plot. They'll give transfer function. How they'll calculate without knowing this information? So that's why I'm explaining for this problem. You have to write answer for the next problem. You write the answer for the next problem. So what is the change in slope till now? Change in slope is nothing but, what is the statement? Change in slope is nothing but, come on, change in slope is nothing but, change in slope is nothing but slope of number of finite poles, slope of number of finite poles and finite zeros at that particular corner frequency. At that particular corner frequency. At that particular corner frequency. Change in slope is nothing but slope of number of finite poles, finite zeros at that particular corner frequency. Come on, write the answer. Come on, write it answer for first question. Write the answer. So, what is the change in slope? Sorry, change in slope. Okay. Come on, omega, corner frequency, space. I am thinking about space first one. First corner frequency. Next, pole R0. Pole R0. P means pole, Z means zeros. Poles are zeros. Next, change in slope. CS means change in slope. Pole means multiply with minus 20. 0 means multiply with plus 20. 0 means multiply with plus 20. Pole means multiply with minus 20. Now come on, corner frequencies. What are the corner frequencies? 2, 10, 20, 50, 100, 200, 500, 600, 1K. 2, 10, 20, 50, 100, 200, 500, 600, 1K. And now tell, at 2, what are there? At 2, what are there? 10 poles. They go at 2, there are 10 poles. So 10 poles. At 10, what are there? At 10, what are there? Come on, they go. At 10, what happened? 20 zeros. 20 zeros. At 20, 30 poles. At 50, they go in the question. 40 zeros. At 100, 50 poles. At 200, 60 zeros. At 500, 70 poles. 800, 80 zeros. 1K, 100 poles. 1K, 100 poles. 1K, they go 100 poles. Now come on, find the change in slope. Find the change in slope. Pole means multiply with minus 20. Zeros means multiply with plus 20. Come on. Pole, minus 20 into 10, minus 200. Minus 200. Next, plus 20. Z means zeros, plus 20. Plus 20 into 200. Plus 20 into 20. Plus 400. Next, minus 20 into 30. Minus 600. Next, plus 800. Next, minus 1000. Next, plus 1200. Next, minus 1400. Next, plus 1600. Next, minus 2000. That's all. This is the change in slope. ठीक है ना? It is the change in slope. Right. Next. Second bit. So whenever they ask the change in slope, don't draw any question like this. Questions they ask. Don't draw border plot. Never draw the border plot. Directly you can write. You observe at 2, 10 poles minus 200. At 10, 20 zeros. 20 zeros means 20 into 20 plus 400. Pole means negative sign. 0 means positive. Minus 600 plus 800 minus 1000 plus 1200 minus 1400 plus 1600 minus 2000, like that. Pole means multiply with minus 20. Zeros means multiply with plus 20. That's all. Automatically you will get the answer. ठीक है ना? Okay. Next one. Next, second bit. What is the second bit? Second but is find the slope of the line between two corner frequencies. Slope of the line between two corner. And another thing, be remember the change in slope is nothing but new slope minus old slope. This formula you remember. Next one, what they ask, what is the second question they ask? Find the slope of the line between two corner frequencies. Find the slope of the line between two corner frequencies. For example, I will find the slope of the line between 10 to 20. I want the slope of the line between 10 to 20. I will explain for this problem. You have to write answer for that. 10 to 20. So 10 to 20 means what? Greater than 10 and less than 20. 10 to 20. 10 to 20 means greater than 10 and less than 20. Greater than 10, less than 20. Greater means you have to take greater than or equal to. Greater means greater than or equal to. Less means eliminated. So greater means put it equal to. Otherwise, what happened? Greater than 10 means you say that 10 not included. Less than 20 means you will say that 20 not included. If both are not included, you don't get the answer. That's why wherever you are writing greater, there you put it equal to. Wherever less you are writing, you eliminate that. Don't consider. So greater than or equal to means it is in. So it is considered, it is in. Less means out. Less means out. Greater means in. Less means out. Greater means in. Less means out. Now consider all the terms in the transfer function up to 10. Now consider all the terms in the transfer function up to 10. Up to 10. Now consider all the terms in the transfer function up to 10 only. Up to 10. Come on, how many poles up to 10? Number of poles counted 3 plus 1, 4 poles. 3 plus 1, 4 poles. Number of zeros you count 4 plus 2, 6 zeros. 4 plus 2, 4 plus 2, 6 zeros. 6 zeros. Now pole 0 cancel it. Pole and 0 cancel it. Now resultant is what? 2 zeros. 2 zeros means how much? Each 0 20. 2 zeros means what? Plus 40. Check it, 10 to 20, how much is there? Plus 40. Here how much is there? Plus 40. That's all. So 10 to 20 plus 40 plus 40. That means what you have to do? Whenever they ask the change in slope between any two frequencies, count the slopes and zeros up to the first corner frequency. Count the slopes and zeros up to the first corner frequency. Then get the resultant. Get the resultant. Then we can get the resultant slope. So count the number of poles and zeros up to the first corner frequency and then get the resultant slope. So now I can write answer for this. Come on, write the answer for the second question. Find the change in slope. Find the slope of the line between two corner frequencies. Come on. Come on. So we have to find between two corner frequencies. So bola second bit. So first I want 2 to 10. Second bit. I want 2 to 10. 2 to 10 means greater than 2, less than 10. We can put equal to. Greater than or equal to 2, less than 10. Greater than or equal to 2, less than 10. Come on. Greater than or equal to 2, less than 10. Now 2 is included. 2 is included. 10 is out. 10 is out. In the transfer function, consider all the terms up to 2 only. Up to 2, what are the terms are there? 5 and 2 only. Up to this, na? Only up to 2 means this only. Up to 2 means up to this. Come on, how many poles? Up to 2 means number of poles are 10. Number of zeros are 5. Number of poles are 10. 10 poles, 5 zeros. Resultant is 5 poles. 5 poles means what? Minus 100. Minus 100 dB for decade. So between 2 to 10, the slope is minus 100 dB for decade. Minus 100 dB for decade. Next, similarly, below 2 to 10 completed. So what is the statement here? I told, consider all the terms to get the slope of the line between two corner frequencies to get the slope of the line between two corner frequencies omega 1 to omega 2, two corner frequencies from omega 1 to omega 2. Consider all the terms in the transfer function. Consider all the terms in the transfer function up to omega 1 only. Up to omega 1 only. Come on, now do it. Up to omega 1 means here 2. Consider up to only 2. We consider up to 2, na? So 10 poles, 5 zeros. Similarly, do it next. Second bit is what? This is the first bit. Second bit is 20 to 50. Come on, do it. 20 to 50. Come on. Greater than or equal to 20 to less than 50. Less than 50. So now what happened? 20 is in. 50 is out. 20 in. 50 out. Consider all the terms up to 20. Consider all the terms up to 20. Come on, consider all the terms up to 20. 20, up to 20 consider. Up to 20 means up to this. This is up to 20. Come on, consider all the terms up to 20. Up to 20 means up to this. How many poles? 30 plus 10. 40 poles. So 40 poles. How many zeros? 25 zeros. 25 zeros. What is the resultant? 15 poles. 15 poles means how much? Minus 300 dB for decade. Minus 300 dB for decade. That's all. Minus 300 dB for decade. Next. Okay, na? Next, third one. Third is what? 200 to 500. 200 to 500. Third one is 200 to 500. 200 to 500 means greater than or equal to 200 to less than 500. Greater than or equal to 200, less than 500. Means 200 is in. 500 is out. 200 is 1. Next. 500. Count up to 200. Count all the terms up to 200. All the terms up to 200 means up to this. Below 200 only I have to consider. This is for first one. This is for second one. This is for third one. Come on, count it. 50, 80, 90. So 90 poles. How many zeros? Count it. Zeros you count. 60, 40, 100, 125. So 125 zeros. Resultant 35 zeros. 35 zeros means plus 700. Next, fourth one. Fourth one. Fourth one. High frequency asymptote. High frequency asymptote means infinity. High frequency asymptote means infinity. You should consider all the terms up to infinity. Consider all the terms up to infinity. Come on, count it. Means all should be considered up to infinity. This is the fourth one. How many poles? Tell. Up to this 90. 90. 160, 260. So 260 poles. How many zeros? Tell. How many zeros? How many zeros? Up to this 125. Up to this 125 na? 125, 205. 205. So 205 zeros. 55 poles. That means minus 1100. Minus 1100. That's all. This is a change in slope of the line between two corner frequencies. Slope of the line between two corner frequencies. This is what above 1000. Above 1K is slope is minus 1100. 200 to 500 is plus 700. 20 to 50 is minus 300. 2 to 10 is minus. I hope you got it. Right. Next one. Third bit. What is the third bit? Find the slopes around the following corner frequencies. One is 2, 20, 200, 1K. What is the meaning of around? Around means around. Around means below and above. Around omega 1 means below omega 1, above omega 1. For example, around 10 if I say, below 10, above 10. Around 10 means below 10, above 10. Below 10 and above 10. Less than 10 means 10 should not include. More than 10 means 10 should be included. Less than 10 means 10 should not include. So this is out. 10 greater is there, put it is equal to. That means this is included. Greater than or equal to. Greater means included. Less means out. So count all the terms without 10. Count all the poles and zeros with 10. So count all the poles and zeros less than 10. Count all the poles and zeros up to less than 10. Next, count all the poles and zeros up to 10. Up to 10. Once 10 included, once 10 is excluded. Then automatically we'll get the answer. So here 10 is out. Here 10 is included. Come on, 10 out. 10 should not be there. So for example, you take here 10 should not there, means up to this. 10 should not there, means up to this. Come on. Count all the poles up without 10. Less than 10 you count. So 4 poles and 2 zeros, resultant is 4 poles, 3 plus 1, 4 poles plus 2 zeros, resultant is 2 poles, that means minus 40. Next, with 10, 10 included. 10 included means how many poles? 4 poles only. But how many zeros? 4 plus 2, 6 zeros. Resultant is 2 zeros. 2 zeros means what? Plus 40. So that means change in around 10, the change in slope we find. Around 10, below 10 is minus 40, above 10 is plus 40. Check it, below 10. Below 10, what is the slope? Minus 40. Above 10, what is the slope? Plus 40. So like this we can get the around. Around means below and above. Around means below and above. So around means below and above. Be remember. Around omega 1 means below omega 1 and above omega 1. Around omega 1 means slopes below omega 1 and slopes above omega 1. Slopes below omega 1 and slopes above omega 1. That's all. So now come and get the answer. So around omega 1, around 2. Below means excluded, above means included. Below omega 1 means omega 1 is not included. Below omega 1 means omega 1 not included. Here omega 1 not included, here omega 1 included. That's all. For example, around 2. Less than 2. Greater than or equal to 2. Greater than or equal. Greater means put it equal to. Greater than or equal to 2. Come on, less than 2. What is there? 2 should not there. 2 should not there means less than 2. 2 should not there means only 5 zeros. Only 5 zeros. So that means what? Plus 100. Here without 2. 2 is excluded without 2. Here with 2. So here 5 zeros. Plus 100. Next with 2 you calculate. With 2. 2 included. If 2 included, what you are getting? Tell. 10 poles, 5 zeros. 10 poles, 5 zeros. Resultant 5 poles. 5 poles means what? Minus 100. Resultant is 5 poles. 5 poles means minus 100. Minus 100. Next, bolo. Come on, around 20 you do it. Do by yourself, around 20. Around 20. Less than 20. Greater than or equal to 20. Here without 20. Less than 20 means without. Here with 20. Now write the term without 20. Now write the term without 20. Without 20, write the term. Count it here without 20. 20 should not there, means up to this. 20 should not there. That means what happened? 10 poles, 25 zeros. 10 poles, 25 zeros. 15 zeros. 15 zeros means plus 300. Next, with 20 you calculate. Now 20 included. 20 included means what happened? 40 poles, 25 zeros. 40 poles, 25 zeros. 15 poles, minus 300. So this is around 20. Similarly, we can do around 500, around 1K. You do by yourself, come on. You do and tell the answer. Next, do around 500, around 1K. Come on. Do by yourself. Come on, ho gaya? What is the answer? So transfer function you didn't write. Yes, right, man. Come on, write it. Completed. Sorry, do homework. Okay. I'll do only 500. 1K do at least homework. 500, around 500. Around 500. So less than 500, greater than or equal to 500. Year in. Sorry, year out. Less means out. Greater means in. Less means out. Greater means in. 500. Without 500 already written. Write it without 500. How much? 80, 90. 90 poles. How many zeros? How many zeros? 125 zeros. 35 zeros. Plus 700. Include 500. If include 500, like this. 80, 90, 160. 160 poles. How many zeros? 125 zeros. Now what happened? How much? 35 na? 35 poles. So minus 700. That's all. Now do by 1K by yourself. Okay. Next problem. I hope it is clear. Okay. Next problem. Put the heading. Any doubt in this? Sri Charan?
Yes, sir.
Tell Jaldi.
In this, we take greater than means we should take the right side, no, sir.
What right side?
The poles and zeros means from 2, we are taking the left side poles and zeros, no, sir.
Left side only. You should not take right.
Greater than also,
2 and it is less than 10 ani. Greater than 2 and less than next corner frequency. That is the meaning.
Okay, sir. Okay, sir.
That's all. Next one. Write it. Finding transfer function from the transfer function from the magnitude plot. This is very, very important. Generally 70% in the Bodo plot, they'll ask on this topic only. Transfer function from magnitude plot. Listen carefully. Transfer function from magnitude plot. From magnitude plot. ठीक है ना? Right. Listen. Find the transfer function. Find the transfer function to the given asymptotic magnitude plot. To the given asymptotic magnitude plot. ठीक है ना? Right. Draw the plot. Come on, do it. Default dB for decade aya. Default dB for decade. No need write. Next problem onwards, I don't write. You consider default dB for decade. What is the procedure? Tell. What is the procedure? First, observe the initial slope. Step 1. Observe initial slope. Step 1. Observe the initial slope. Observe initial slope. It gives poles and zeros at origin. It gives poles and zeros at origin. Step 2. Find the change in slope at each and every corner frequency. Find the change in slope at each and every corner frequency. If change in slope is positive, consider finite zero. Change in slope is positive, consider finite zeros. If change in slope is negative, consider finite poles. Consider finite poles. Next, step 3. Find the K value by using known magnitude at known frequency. Find the K value by using known magnitude at known frequency. Come on, do it. Come on, Bhaiya. So first, what is the initial slope here? Initial slope is, come on. What is initial slope here? Initial slope is 0 dB per decade. That means no poles and zeros at origin. No poles and zeros at origin. That means no poles and zeros at origin. Next command. Find the change in slopes at each and every corner frequency. Find the change in slopes at each and every corner frequency. Come on, find the change in slope at each and every corner frequency. Come on, find your change in slope. What is the new slope? Minus 40, minus 0, change in slope. Minus 40 minus 0 become minus 40. Minus 40 means what? 2 poles. 2 finite poles. Now find here change in slope. New slope minus 20. Minus of old slope minus 40. New slope minus 20 minus of minus 40. Becomes what? Plus 20. Plus 20 means what? 1 finite 0. Plus 20 means 1 finite 0. Minus new slope minus old slope. Now find change in slope here. What is the new slope? Minus 40 minus of old slope minus 20. That means minus 20. That means 1 finite pole like this. Then we have to write the terms. Okay, more simplest way is take the previous slope, add to next slope. 0 plus minus 40, minus 40. That's all. 2 finite poles. Take opposite sign, add to next. 0 opposite sign, 0 only. 0 plus minus 40 means minus 40. Minus 40 opposite sign tell plus 40. Plus 40 minus 20. Become what? Plus 20. Directly we can write plus 20. Opposite sign means plus 40. Add to next. Opposite sign, add to next. Opposite sign, add to next. Opposite sign, add to next. Opposite sign plus 40. Plus 40 minus 20. Become plus 20. 1 0. Opposite sign plus 20 add to next minus 40 plus 20 minus 40 minus 20 like that. Okay, na? Now write the transfer function. So g of s h of s equal to, first you have to write the term k. K initial slope is 0. Initial slope 0. Initial slope is 0. Now find change in slopes. So already we find it. So no pole and 0 at origin. Already we written. No pole and 0 at origin. No pole and 0 at origin. Next. Here change in slope, you already find it. 2 finite poles. That means what I should write? 1 plus s by 2. You have to write in time constant form. Whole square. 2 finite poles. 1 plus s by this corner frequency. 2 na so square. Next here 1 finite 0. So what I will write tell here? 1 plus s by 10 whole power 1. Next here 1 finite pole. Negative na 1 finite pole. 1 finite pole means what I will write? 1 finite pole means what I will get? 1 plus s by 20 whole power 1. That's all. ठीक है ना? Now get the k value. I hope you got it. Got it na? What is the k value? Anybody? Oh, you didn't have lunch? I also didn't have lunch. Yeah? So what is the time now? 2:10 na? So we'll take break at 2:30. 2:30 or 3. What time you want break? K100. Very good. K100. What time break you want? Three o'clock or 2:30? Sorry, 2:45 will take. Now, now break. No, man. 2:30 I will give. Okay. Only 2:30 I will give. Now come on. Get the k value. Listen, very important. Finding k value, very, very important. Listen, Bhaiya. Generally, all of you write the terms correctly. We'll do the mistake only while finding the k value. Some students, what they will do, this 40 equal to 20 lakh k, they'll take directly. 40 equal to 20 lakh k, they'll take. And then directly they'll write k equal to 100. In this problem, it is correct only, but it is not valid for all the problems. Why? Because the k value depends on this magnitude as well as initial slope. This magnitude slopes, listen, I will tell the procedure so that you can solve the correctly. Listen. To find the K value, first you have to observe the magnitude at known frequency. You have to observe the magnitude at known frequency. Here, where we know the magnitude? We know the magnitude 0.1 at which 40. 0.1, 40. 40 at 0.1. 40 at 0.1. So I can write. So 40 dB at a frequency of 0.1. 40 dB at a frequency of 0.1. 40 dB at a frequency of 0.1. ठीक है ना? 40 dB at a frequency of 0.1. Now we can write all these terms, okay, in dB, because this is in dB. Write all these terms in dB. This 40 in dB na. Write all these terms in dB. So what is that? 20 log K. 20 log K. dB term means apply 20 log, that's all. dB means apply just 20 log. dB means apply just 20 log. So 20 log K. 20 log K. Now what is the dB term for 1 plus S by 2 whole square? Pole dB means apply 20 log. So 20 log you apply. Pole means minus. You remembered or not? For n finite poles, what is the dB term? Minus 20 n log of root of real square plus imaginary square. For n finite zeros, plus 20 n log of root of real square plus imaginary square. Come on, write the dB term. 2 poles now minus 40. 20 into 2 means minus 40. Log of root of real square means 1. Imaginary square means omega by 2 whole square. Imaginary square means omega by 2 whole square. Next, 1 plus S by 10 minus, come on, what I will get? Minus 1, 0. What is the dB term? Minus or plus? Plus, because it is 0. Plus, what is the dB term? 20 log of root of real square plus imaginary square. 1 plus omega by 10 whole square. 1 plus omega by 10 whole square. Next, what is the dB term for this pole? Minus 20 log of root of real square plus imaginary square. 1 plus omega by 20 whole square. 1 plus omega by 20 whole square. ठीक है ना? Now substitute omega equal to 0.1. Now substitute omega 0.1. This is 0.1. This is 0.1. This is 0.1. Now substitute omega equal to 0.1. You substitute omega 0.1. What you are getting, tell here? 0.1 by 2. 0.1 by 2 means it is very small. 0.05 whole square, still small compared to 1, because Bodo plots are approximated plots. Bodo plots are approximated plots. Approximated means we have to calculate K value approximately only. Bodo plot is approximated. You have to calculate K value approximately. That means in the root always consider only one term. In the root always consider only one term. So that means whatever the small term is there, that is neglected. This is small. Neglect it. This is small. Neglect. So this is small. Neglect. This is small. Neglect. This is small. Neglect. This is neglect. Then what is left to tell? 40 equal to below 20 log K. 40 equal to 20 log K. 22 ja. Then K equal to what? 10 square means what? 100. K equal to 100. That's all. This is the answer. Now if you write the transfer, this is by the procedure. I'll tell shortcut also. So this is by the procedure. Simple shortcut is, listen. Simple shortcut is, while finding the K value, what you have to do? Compare the corner frequency. Compare the corner frequency. Compare the corner frequency. Corner frequency. Compare the corner frequency with the frequency where we know the magnitude. while finding the K value, compare the corner frequency with the frequency where the magnitude is known. Where the magnitude is known. Compare the corner frequency with the frequency where the magnitude is known. So if corner frequency greater than or equal to, if corner frequency greater than or equal to the frequency where the magnitude is known, then neglect that corner frequency term. Then neglect that corner frequency term while finding the K value. Compare corner frequency with the frequency where the magnitude known. If corner frequency greater than or equal to the frequency where the magnitude known, then neglect that corner frequency term while finding the K value. Write that statement. To get the K value, to get the K value, to get the K value, compare the corner frequency, compare the corner frequency with the frequency, where the magnitude is known, where the magnitude is known, where the magnitude is known, where the magnitude is known. If corner frequency, F means corner frequency is greater than or equal to the frequency where we know the magnitude. If corner frequency is greater than or equal to the frequency where we know the magnitude, then neglect corner frequency term while finding the K value. While finding the K value. That's all. ठीक है ना? So now do it. For example, here this problem is solved. For example, see corner frequency is what you take here. For example, here. See, listen. So where we know magnitude 40 dB, I know 40 frequency of what 0.1. And compare this corner frequency. Default K is considered. Default K and poles and zeros at origin exist, consider. By default, K and poles and zeros at origin is considered by default. While finding the K value, always consider K and poles and zeros at origin. K and poles and zeros at origin. Okay? No poles, no zeros at origin. That's why K. Next 2 consider or not. 2 is greater than 0.1. This 2, this 0.1 you have to compare. Corner frequency 2 greater than 0.1. Don't write in dB. It is neglected. So you once neglect 40 log 1 become 0 na. Here also if you neglect 20 log 1 become 0. If you neglect here 20 log 1 become 0. All are become 0. That's why written 40 equal to 20 log K. So K equal to 100. So that's why neglect. Once it is satisfied, corner frequency term neglect. Even if consider, that will become 0. Even if consider, that will become 0. Simply wasting the time na. Why to consider, why to write all the terms in dB, why to make equal to 0, wasting the time. That's why simply follow this procedure. Corner frequency, the frequency where we know the magnitude, you compare. So corner frequency greater than or equal to is there, simply neglect the term. So for here 2 greater than 0.1, neglect. 10 greater than 0.1, neglect. 20 greater than 0.1, neglect. What is left? K only. That means apply dB for this. Apply dB for this. So, or 20 log of terms you write, then also you'll get the answer. 20 log of terms. Which terms I consider? Only K, remain all are neglected. So, now we simplify this. Then automatically what you will get? K equal to what? 100. K equal to 100. That's all. Okay, na? K equal to 100. Like this. Directly we can write the answer. Now, what is the transfer function we got? G of S, H of S equal to bolo 100 into 1 plus S by 10, I think. Na? 1 plus S by 10, correct? Next, divided by 1 plus S by 2 whole square into 1 plus S by 20 whole square. 1 plus S by 20 whole square. Now this in the time constant form, if you write, what I can write? 100 into 1 plus 0.1 S divided by 1 plus 0.5 S whole square into 1 plus 0.05 S whole square. That's all. This is the what? This is the last term power is 1. This is the what? Time constant form. This is the time constant form. Time constant form. And one more thing, sometimes in the exam, they are giving in pole zero form. Sometimes in the exam, they are giving in pole zero form. Then what you have to do? This convert into pole zero form. So G of S, H of S equal to, how to convert? LCM you have to take 100 into below 10 plus S by 10 divided by 2 plus S by 2 whole square into 20 plus S by 20. Now simplify this, come on. So what I will get tell here? So this 100 into this goes to numerator, so 2 square into 20. This will come to denominator into 10 into what? S plus 10 divided by S plus 2 whole square into S plus 20. So now simplified, 0, 0 cancel. So 800 I think. 800 into S plus 10 by. So you should observe carefully. Either the given answer is pole zero form or time constant form. This is called pole zero form. If you given time constant form, directly K will be there here 100. If you given pole zero form, then you need to take LCM and then you have to get the answer. Okay, na? Is it clear? Equal to also neglected. Na already I written na here. Dekho, equal to also neglected. Greater than or equal to I put it na. Next, one more question. In the break time, solve this question. Okay, I'll write the question. Find the transfer function. Find the transfer function. Find the transfer function. To the given asymptotic magnitude plot of a minimum phase system. Find the transfer function to the given asymptotic magnitude plot of a minimum phase system. Okay, na? Come on, do it. Come on, do it. Two, 10, 20, 50, 100, 200, 500. Okay. Solve this. All of you solve this problem. Sorry, take the break because many people are not at the lunch, I think. They're asking break for lunch. Many people have a lunch. Take half an hour break, no problem. Today we'll move aram se. Maximum time we'll spend. Take half an hour break. Okay? Okay, we'll start. Completed, na? Or solve that problem? Okay, point 1. Okay, I'll solve it. Sumant. Right. Right. No doubt. So now solve it. So G of S, H of S equal to K, first K, initial slope plus 40. This is initial slope. IS means initial slope. Initial slope plus 40 means initial slope plus 40. Plus 40 means what? 2 zeros at origin. So K S square. 2 zeros at origin. Next, find here change in slope. Simply opposite sign add to next. Opposite sign. Simple logic. Opposite sign add to next. Plus 40 opposite sign minus 40. Minus 40 minus 40 minus 80. Minus 80 means 4 poles. 4 finite poles. Minus 80 means 4 finite poles. So that is 1 plus S by 2 whole power 4. 1 plus S by 2 whole power 4. 1 plus S by 2 whole power 4. Next, find here change in slope. Change in slope you find next. So what is the opposite sign? Add to next. Opposite sign plus 40. Plus 0 means plus 40. Plus 40 means 2 zeros. Plus 40 means 2 finite zeros. 2 finite zeros means 1 plus S by 10 whole square. 1 plus S by 10 whole square. Next, here again find change in slope. Opposite sign and add. 0 opposite sign add means minus 60. So minus 60 means 3 finite poles. 3 finite poles. That means what I will get? 1 plus S by 20 whole power 3. Next, find change in slope. Opposite sign add. Opposite sign means plus 60. Plus 60 plus 80. Plus 140. Plus 140 means 7 finite zeros. 7 finite zeros means 1 plus S by 50 whole power 7. Next, find change in slope here. What is change in slope? Opposite sign add. Minus 80 means 4 poles, finite poles. So that means I can write 1 plus S by 100 whole power 4. Next, opposite sign and add. Opposite sign 0. Add. So plus 100. Plus 100 means 5 zeros. 5 zeros means what? 1 plus S by 200 whole power 5. Next, opposite sign and add. Opposite sign means minus 100. Minus 100 means 5 poles. Minus 100 means 5 poles. That means what you will get? 1 plus S by 500 whole power 5. Next, opposite sign add. Plus 80 means 4 zeros. So 1 plus S by 1K whole power 4. Whole power 4. That's all. This is the what? This is the transfer function. I hope same answer you got. Is it correct? Is it correct? Got same answer? Yes or no? Okay. Right. Okay. Now find the K value. So K, see where we know is minus 60. So minus 60 at a frequency of 0.1 equal to 20 log. What are the terms consider? Ks square default consider. Next 2 greater than 0.1 neglect, 10 greater than 0.1 neglected, all are neglected. That's all Ks square. That means minus 60 into 20 log K, log A B na, log A plus B, 20 log K plus 20 log S square means what happened? 40 log omega. S is magnitude you have to consider na. 20 log magnitude of this. You can write here magnitude. 20 log of magnitude of this. S is called J omega. J omega into omega square. K omega square. Or you write here K omega square. K omega square. S is called J omega. Magnitude means what? Omega square. Na? So we can write K omega square. Remain all are neglected. K omega square. In place of S, put it omega. That's all. K omega square. So that means 40 log omega. Omega is what? 0.1. Then get the answer. Minus 60 equal to 20 log K. Then 40 log 0.1 is minus 40 na? Yes or no? Log 0.1 minus 1 means minus 40. Then what happened? Minus 20 equal to 20 log K. K equal to 10 power minus 1 means 0.1. K equal to 10 power minus 1. That equal to 0.1. That's all. K equal to 0.1. Next problem. Next problem. Repeat the above problem. Come on. This is minus 60, year 2, year 10, 20, 100, minus 20, plus 20, plus 80. Come on, do it. Find the K value. Find the answer. Come on. Akash,
Hello?
Adel.
So how do we know that when the slope will cut the frequency axis?
That will come, na? Wait some more time.
Okay. Sir.
Completed? Eight. See, it not required always initial magnitude. To find the K value, it is not required always initial magnitude. They can give magnitude at any frequency here. In the border plot, they can give magnitude at any frequency. So you should be able to find by using that magnitude. So here, if I write transfer function, so G of S H of S equal to G of S H of S equal to first K, initial slope minus 60 means S cube, minus 60, 3 poles. 3 poles means S cube. S cube. Now find here change in slope. Here find change in slope. Opposite sign add to next. Opposite sign plus 60 minus 20 plus 40. Plus 40 means 2 finite zeros. That means I can write 1 plus S by 10 whole square. Next find here change in slope. Opposite sign add, so plus 40. Again 2 finite zeros. So that means 1 plus S by 20 whole square. Next opposite sign and find here. Minus 40. Minus 20 plus 60. So plus 60. Plus 60 means 3 finite zeros. So that means 1 plus S by 50 whole power 3. Next opposite sign add here 0 na minus 80. Minus 80. Minus 80 means 4 finite poles. That means you can write 1 plus S by 100 whole power 4. Now get the answer. Now get the answer. So where we know the magnitude at 2 is 0 dB. 0 at a frequency of 2. That equal to bolo. Now compare. So 20 log of K S means omega. So omega cube. K by omega cube is K by omega cube. And remain finite terms compare. 10 is greater than 2, not considered. 100 is greater than 2, not considered. 20 greater than 2, not considered. 5 greater than 2. 5 50 kada. 50 greater than 2, not considered. That's all. Now solve it. This can be written as 0 equal to 20 log K minus 60 kada. 60 log omega. K by omega cube na. So 60 log omega. So now omega is what? 2. So that means 20 log k equal to what? 20 log 60 log 2 power 3. 60 log of 2, we can write it at 2, 20 log omega power 3 we can write. Now 20 cancel, log cancel, k equal to what? 2 power 3, 8. So this is the procedure. But simple logic is, listen, this is by the procedure. This is by the procedure. But when given here 0 dB only, if you not given 0 dB, it is not 0 dB magnitude, it may be any magnitude. Here mentioned 0, then only you have to consider it is 0 dB. Otherwise, you should not consider. Otherwise, you should not consider. Simple logic is, so complete enough this one. So k equal to 8. Here substitute 8, that will become the answer. But simple logic is, whenever plot moving with the initial slope magnitude in dB, whenever plot moving with the initial slope of, but here mentioned 0 dB, initial slope, like this. Whenever plot moving with initial slope of minus 20 and dB for decade, minus 20 and dB for decade, and intersect at omega 1 in case, then the k is nothing but directly we can write omega 1 whole power n. The k is nothing but omega 1 whole power minus n. But it is valid with only initial slope, not with middle slope. It is valid with only initial slope. Initial slope line only it is valid. So here this slope is there, here intersect depth by 75 something. I'll write means wrong. It is valid with only with initial slope. For example, here initial slope how much? Minus 60. So minus 60 can be written as what? Minus 20 into 3. So minus 20 into 3. This 3 becomes a power of 2. 2 power 3 how much? 8. 2 power 3 how much? 8. Simple logic. Omega n, omega 1 whole power n. So in case if it is with a positive slope, in case it is with a positive slope like this, this is 0 dB. This is magnitude in dB. In case it is positive slope like this, this is omega 1. This is omega. This is initial slope. Initial slope plus 20 n dB for decade. Then what is k value? The k is nothing but omega 1 whole power minus n. The k is nothing but omega 1 whole power minus n. Omega 1 whole power minus n. That's all. Omega 1 whole power minus n. With a positive slope, power of minus n. With a negative slope, power of n. Remember this two. Remember this two. Take a simple shortcut. Sometimes in the exam, they are giving like this. Find the transfer function. Come on. All of you do this. To 10. Come on, find the transfer function. Come on, do it. Abdul, what is the doubt?
సార్ ఇందాక ఆ ప్రాబ్లమ్ లో ఎందుకు నెగ్లెక్ట్ చేశారు సార్ వాల్యూస్ 1 + s⁻n అండ్ అది వాల్యూస్ వచ్చాయి కదా సార్
Which problem?
మనకి ఈ ప్రాబ్లం 9 పేజ్ నెంబర్ 9
Tell.
1 + s/s/10 1 + s/20 ఎందుకు నెగ్లెక్ట్
I already told what you are doing, man. Here, what is the statement I told?
ఓకే కార్నర్ ఫ్రీక్వెన్సీ గ్రేటర్ దెన్ ఒమేగా నెగ్లెక్ట్ కార్నర్ ఫ్రీక్వెన్సీ అంటే వాల్యూ మనం ఏ వాల్యూ ఎలా
Neglect, compare it. 10 is greater than 2 or not?
yes
Neglect it, that's all.
okay
No, sir, I will write all the terms. You write is up to 2. Then smaller term you neglect. Finally, you will get the same answer.
okay
Or follow this simple shortcut. I told it already. To the problem, we solved it already.
అర్థమైంది సార్ అంటే కొంచెం అక్కడ
Got it, na?
got it.
Completed? K25, yes, correct. Right. So, right. So, what happened here? Listen, simple logic. So, here nowhere we know the magnitude. Nowhere we know the magnitude. But what they are telling, in case plot with come -40 and go on, in case extend, it will intersect the 0 dB line at 5. So, this is initial slope only, na? This is initial slope. The plot is moving with the initial slope of -40. And in case there is no change in slope at 2, then intersect at what? 5. It intersect at 5. It is intersected at 5. Okay, na? It intersect at 5. So then I can write -40 into 2. So that 2 will become power of 5, na? That 2 will become power of 5. That means what I can write directly, GH of S equal to, we can write, this is -40 means -20 into 2. That 2 will become power of 5. That means 5 square means 25. Initial slope is what? -40. -40 means S square. -40 means S square. Next, change in slope here we find. What is the change in slope here? Opposite sign add means +40. +40 means 2 zeros. That means we can write it as 1 + s/2 whole square. Again, change in slope -40. -40 means you can write again 2 poles. 2 poles means 1 + s/10 whole square. That's all. This is the what? Answer. See, in case if you don't remember this, it is very difficult to find the K value here. So that's why be remember this. Why it is difficult means actual at 5 magnitude not 0. At 5 magnitude not 0 because the plot is this. This is the plot. This is the plot. Not this is dotted lines is the plot. Here we don't know magnitude. 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 Then we cannot find. That's why be remember this. So that where is intersect the 0 dB line? If that frequency knows it, directly we can find the what? K value. Okay, be remember this logic. Okay, na? Next problem. Find the transfer function. Next problem. Come on, solve this. Come on, do this. Venkatesh.
సార్ ఒకసారి బ్యాక్ సైడ్ ప్రాబ్లం చేయండి
Tell.
సార్ ఇక్కడ ఈ 5 అనే పాయింట్ ఇవ్వకపోతే ఈ ఎస్
Not
స్క్వేర్
right K value.
ఈ ఎస్ స్క్వేర్ అనేది పైన కొత్త కదా సార్
S square ఎందుకు పైకి వస్తుందా? Initial
అంటే-
slope how much? -40 na?
ఎస్ సార్
That S square belongs to initial slope.
ఓకే సార్ ఓకే సార్ ఓకే సార్
Shreya.
So could you please explain in this on page number 10F itself, how do we get 25?
What is this logic? This logic you understood?
Above one?
This logic. Initial slope -20 and K will become omega 1 whole power n.
No,
Na?
sir, I did not get that.
That you have to remember, shortcut that is.
Okay.
Same way, here -20 and -20 into 2 na?
Yes, sir.
That 2 will become 5 power. This n will become what? Omega 1 power n na? Hello?
Yes, sir. Yes, sir.
Here also what is omega 1 value here?
5.
5 power how much? How many times of 20 is there here? 2 times na?
Yes, sir. Understood.
That's all.
Thank you, sir.
Okay. Now come on, get the answer for this. All of you, what is K value 10? 15.84. Very good. Come on, write the transfer function. G of S, H of S equal to K. Initial slope plus 20 means yes. Change in slope we find here. What is the change in slope? Tell. New slope -20. Sorry. Opposite side -20. -20 become what? -40. -20 becomes -40. -40 means 2 poles. That means I can write 1 plus S by 2 whole square. Next year, find change in slope. Change in slope, opposite sign and add means +20. +20 means 0. 1 finite 0. That means what I should write? 1 plus S by 5. Next, find change in slope here. -20. 1 pole. That means what happened? 1 plus S by 10. 1 plus S by 10. Now find the K value. So 24 here. So 24 equal 24 at what? 1. Equal to bolo 20 log of consider K 0 at origin means omega 2. 2 greater than 1. So neglect. 5 greater than 1 neglect. 10 greater than 1 neglect. Now solve this. 24 equal to 20 log K plus 20 log omega. What is omega value? 1. So that means K equal to how much? Tell. 10 power 1.2. So 15.84. That's all. Next problem. Find the transfer function. Come on, do it. Find the K value.
సార్
Tell.
ఇక్కడ ఒమేగా ఈక్వల్ టు 1 కదా సార్, ఇక్కడ 1 ఉన్నప్పుడు అది అండర్ 20 లాగా అండర్ రూట్ తీసుకోవచ్చు కదా సార్.
Why? 1 is greater than 2 or 2 is greater? 2 is greater than 1 or less than 1?
గ్రేటర్ దెన్.
Then how can you consider? What is the statement? You read that statement. Don't ask blindly, na. You follow the statement. What is the statement I told? This statement, remember this statement. Corner frequency greater than or equal to frequency where we know magnitude, then corner frequency term neglected. Okay?
సార్
Otherwise, like this, you consider. After that, omega value substitute, small value neglected. Finally, we'll get the same answer. Okay, na?
ఓకే సార్.
All the terms write in dB. Each and every problem, all the terms you write in dB. Then omega value substitute. In the root, whatever the small term is there, that you neglect it.
సరే సార్. ఓకే సార్.
Solve it. Same answer you will get. What is the K value? Anybody? What is the K value? 1584. Very good. Come on. So G of S, H of S equal to K S square. 24 at 0.1 equal to 20 log K plus bolo S square. Always poles and zeros at origin consider 40 log omega. Poles and zeros at origin always consider. So directly 20 log you apply for this. You have to apply 20 log K omega square. Omega square. Now what I'll write? 20 log K plus 40 log omega. 40 log omega. 24. Omega 0.1 is substitute here. You substitute here 0.1. Then minus 40. Minus 40, this come this side 64 equal to 20 log K. K equal to what? 10 power 3.2. 1584 point, I think 89. Next problem. 1584.89 you will get. Here also 24, here also 24, but K value not same. Check it. Because K is depends on what? K depends on magnitude, initial slope, as well as what? Magnitude, slope, frequency. It depends on many factors. Okay? Next problem. Find the transfer function. Come on, what is the answer? 0.1584. Come on, Guruji, all of you. Write the G of S, H of S. Here also I taken 24 only. Some people below this is there and they'll take minus 24. Wrong. This omega, this horizontal line can draw at 0, can draw at minus 20 plus 100 plus 1000. We can draw wherever you want. Unless until mention the magnitude, you should not consider the magnitude here. Don't take here 0, it is wrong. They didn't mention, so you should not consider. So whatever the sign is given, that you have to consider. They can give at anywhere. We can draw here also. We can draw here. We can draw here. So unless until mention magnitude to this line, you should not consider any value. So what is the answer? K by S square. Because minus 40 means S square. K by S square. Now tell 24 at 0.1 equal to 20 log K by omega cube. S square means S plus put it to omega. So omega cube. So 24 at 1 equal to 20 log K minus 60 log omega. Minus 60 log omega. Omega 0.1. So that will become plus 60. Plus 60 come this side. Minus plus 60 come this side. Minus 60. Yes or no? Then what is the answer? Plus 60 only, na? Square kada? Okay, sorry, here square. Square means here 40. Right, correct. So 40 plus 40. Plus 40 come this side. So minus 16. Minus 16 equal to 20 log K. K equal to 10 power minus I think 0.8. You solve this, you will get 0.1584. Next problem. Point 5. 1 0. Come on, get the answer. Find the transfer function. Come on, Guruji. Come on, solve it. Shreya?
Sir, I am okay. I am like omega. I was asking about omega cube only.
Huh?
Omega cube.
Okay. Right. Next. Write the answer. Anybody answer? What is K value? Anybody? Anybody K value? No. 31.62. No. ఎవరు? Right, next. Come on. So G of S, H of S equal to K. Anybody answer? Nobody telling answer, man. This one fellow correct answer, 7 point, yes, I think. Small mistake is there, even 7 point. 5.28 is wrong answer. Anybody? Come on, Guruji. Nobody telling. Tell the answer. Listen, all of you listen. K. What is the initial slope? Tell 0. 0 means no poles and zeros at origin. Next, find change in slope here. Change in slope is plus 20. Plus 20 means one finite 0. So that means 1 plus s by 0.5. 1 plus s by 0.5. Now where we know magnitude 24 at a frequency of 1. 24 at a frequency of 1. So that equal to bolo. 24 at a frequency of 1 equal to what? 20 log k. 20 log k. So that is 20 log k. And this 0.5. 0.5 is less than 1. Listen all of you carefully. 0.5 less than 1. That means this term consider. In case greater then we'll neglect. Less means you have to consider. That means 20. What is the term I should consider? 20 log of k into 1 plus omega by 0.5. For this you have to write the magnitudes. For this you have to write the magnitude. Write the magnitude, tell. So that equal to 20 log of k plus, this is actually j omega. J omega, magnitude means real term, imaginary you have to consider. Is equal to j. Here also actually j omega whole square I have to put, but I written directly omega square. Previous case also same thing, j omega, magnitude become omega. Magnitude become omega. Now come on, write 20 log k plus 20 log of what I can write? Tell root of real square plus imaginary square means omega by 0.5 whole square. Omega by 0.5 because 0.5 less than 1 it should be considered. Then substitute omega 1. 24 omega 1 na? That omega 1 is substitute here. If substitute omega 1 by 0.5 how much? 2. 2 square how much? 4. 4 means 1 neglected because it is approximate analysis. In the root, whatever the small term is there, that compulsory you have to neglect. What we did while doing the analysis of Bodo plot, omega tau greater than 1, 1 term neglected. Omega tau less than 1, 1 term neglected. Like that. So here, this term is less, so 1 should be neglected. Now come and write it. This will become what? 1 by 0.5, 2. 2 square 4. 4 root means 2 again. That means 24 equal to 20 log k. 20 log k plus 20 log 2. 20 log 2. 20 log 2. 20 log 2 is 6. If you come this side, 18 equal to 20 log k. K equal to 10 power 0.9. That equal to 7 point, I think 92 or 94, I think. Check it, 7.92, I think 92 or 94. 92 no 94. Any value 92 to 94. Okay. Like this you have to solve. You have to compare this value with this. Then only we'll get the answer. Next. So if this frequency less means that term should be considered. That term should write for that term you have to write the magnitude. For that term you have to write the magnitude. Okay, na? Next problem. Come on, find the transfer function. Asymptotic analysis, I am telling starting onwards. Asymptotic analysis means in the root consider only one. Approximate. Where is the approximation if you consider this one? If you consider one and this term, where is the approximation? Compulsory small term should be neglected. That's all. Listen carefully while explaining. Come on, get the answer. See, whenever log omega given, generally they'll give negative and positive values. Log omega given means generally negative and positive values they'll give. Sometimes by mistake also they used to give like this here. For example, instead of omega, by mistake they'll put log omega. Then you should identify that log is either correct or not. In case all are like this positive values given, then you should identify that log is correct or not. How to identify means, if your log is there means this will become 10 powers. So for example here, this is log omega. Log omega equal to -1. What is omega? Tell 10 power -1. That means omega is 0.1. Automatically this frequency is going to be changed. So here log omega equal to 0. Omega equal to what? 10 power 0 becomes what? Omega equal to 1. Here log omega equal to 1. Omega equal to 10. Omega equal to 10. That's all. So that means this is 0.1. This is 1. This is 10. Like this you have to do the conversion. So by mistake if you give like this log omega, immediately observe this corner frequency 2, 5, 10. And 4 options you observed. In 4 options it is get 2, 5, 10 only. In 4 options also 2, 5, 10 only is there. Then that log is wrong. Generally log is there means negative positive values will be there. Yeah. So otherwise it is wrong. That's all. Simply can neglect that log term. Okay. Simply neglect log term if there is no negatives and zeros. If negatives and zeros is there, generally log term they will mention in the question, no doubt. By printing in local author books, some books now always they used to write log omega, but they should not write. Why? Because Because 1 minute. Vasu? Phone dikh taki. Hello? Tell madam. You can call with can talk with student. Okay. White hat sol. Right. This taki. So right. So now see, whenever log omega given, generally like this negative positive values will be there. Otherwise there is no negative positive values means 99% that log is wrong. Log is there means corner frequency values are going to be changed. Just observe the 4 options. 4 options corner frequency, plot corner frequency same means that log is wrong. That's all. Now write the transfer function. So g of s, h of s equal to command k. So plus 20 means yes. Plus 20 means yes. Change in slope minus 20. 1 plus s by 1. 1 plus s by 1. Change in slope here minus 20. 1 plus s by 10. 1 plus s by 10. That's all. So now find the k value. 24 at a frequency of 0.1. That equal to 20 log. 1 is greater, neglect. 10 is greater, neglect. So k actually j omega I have to write. Previous case also I written just omega. Now write the magnitudes. So what I can write? 20 log k plus 20 log j omega. Magnitude is what? Omega. 20 log j omega magnitude. Here I put magnitude better. So This is magnitude. So now 20 log k plus 20 log omega, that equal to 24 at a frequency of 0.1. Now substitute 0.1 here, it become minus 20. Minus 20 come this side, plus 20. That means 44 equal to 20 log k. Then k equal to how much? Tell. K equal to 10 power 2.2, I think. That means 158.48, I think. 158 point, how much? 158.48, correct. 158.48, correct. Very good. See, in above all the problems you observe, here also 24 I taken, here 24, here 20, everywhere I taken 24 only. But no two plots given the same value of k. So be careful while finding the k value, because k value changes with the slope, initial frequency, so with magnitude, so be careful. So you should be perfect in finding k value. Okay, na? Next problem. I'll solve one more problem that gives the clear idea in finding the k value. Find omega 1 and omega 2. Find omega 1 comma omega 2 and transfer function. To the given asymptotic magnitude plot. Come on, do it. Here, first you have to find omega 1 and omega 2 values. First you have to find omega 1 and omega 2 values. So how to find omega 1, omega 2 values? So here this is 0.1. They given this is 0.1 and 0 dB. Listen here, all of you listen. First you have to find here omega 1, omega 2 values. See, in the border plots, we can find unknown frequencies, we can find unknown magnitudes, we can find even unknown slopes also. Unknown slopes, all the factors in the border plot you can find by using slope formula. So what is the formula for slope? Slope equal to dm by d of log omega. Dm by d of log omega. So dm means difference in magnitude, that is m2 minus m1 by log of omega 2 minus log omega 1. Log of omega 2 minus log of omega 1. Log omega 2 minus log omega 1. But here the condition is the selected line, to the selected line, we should know, we should have only one unknown factor. Whatever the line you are selecting, to that there should be only one unknown factor. For example, if I select this line, omega 2 also unknown, omega 1 also unknown, two unknown factors. Two unknown factors, you cannot get the answer. There should be only one unknown factor. For example, if I select this line, how many unknowns tell? How many unknowns? M2, this is M1, 32, M2, 6, slope malum, initial frequency 0.1. That means final frequency unknown. There will be only one unknown. If I select this line, there will be only one unknown, so that I can get the answer. So find it, minus 20 equal to, this is calculations for omega 1. Minus 20 equal to M2, 6. M1, 32. M1, this is 32. M2, 6. M2, 6 divided by, at 6, what is the frequency? Log of omega 1 minus, at 32, what is the frequency? 0.1. So log of 0.1. Log of 0.1. Now solve this. So minus, come on, solve this. Log omega 1 plus log of omega 1 minus log 0.1 become plus 1 equal to minus 26 by minus 20. Then solve for omega 1. You will get 2, I think. 10 power, you will get, what you will get here? This will become 1.3. Minus minus cancel, then it will become 1.3. 1 with 0.3. The 10 power 0.3 will get omega 1. Approximately, I think 2 radians per second. Approximately, this is 2 radians per second. Similarly, get the omega 2. Similarly, get omega 2. Come on, solve it. Get the omega 2 and find transfer function, all of you. Similarly, get the omega 2. Omega 2, you get it. So select this line slope. See, don't select 0 dB line. Logarithmic 0 dB is not defined. Don't select 0 dB lines. Select this, for example. Next, we want omega 2, select this. Avoid 0 dB for decade line. We select this line. Now tell what is the slope. This is calculations for omega 2. What is the slope? Minus 20. Minus 20 equal to M2, 0. M1, 6. M2, 0. M1, 6 divided by log of, at 0, what is the frequency? 10. Minus at 6, what is the frequency? Omega 2, log of omega 2. Yes or no? At 0, what is the frequency? 10, log 10. At 6, what is the frequency? Omega 2. Now solve this, get the value of omega 2. You'll get, I think, 5 radians per second. Omega 2 is 5 radians per second you will get. Now find the transfer function. Now find the transfer function. So G of S, H of S equal to K. Bolo. Initial slope minus 20, yes. Change in slope here. How much change in slope? Plus 20. Opposite sign add means plus 20. Plus 20 means one finite 0. One finite 0. That is what? 1 plus S by 2. 1 plus S by 2. Next, find here change in slope. So what happened? Opposite sign add. So minus 20. So one finite pole. That means 1 plus S by 5. Next, find here change in slope. So what happened? Minus 40, opposite sign, add it. Opposite sign means minus 20. That means one finite pole. That means 1 plus S by 10. That's all. This is the term. Now find the K value. Now find the K value. Come on. You find the K value. What is the K value? Find the K value. Bolo. Where we knows magnitude here? We knows magnitude at each and every frequency. We knows magnitude here, each and every frequency. At all the frequencies, we knows the magnitude. You take any magnitude at any frequency, the K value same, approximately 4. Approximately 4 you will get. Come on. So what happened? For example, first I can take here. I can take 32 at a frequency of 0.1, or I can take 6 at a frequency of 2, or 6 at a frequency of 5, or 0 at a frequency of 10. 0 at a frequency of 10. Yes or no? So now you select any value. The answer is same. For example, see, first I'll take 32 at a frequency of 0.1. Now tell what are the term consider. 20 log K, 20 log magnitude of K, K by how much? Tell. K by j omega default consider. Magnitude of 2 greater than 0.1 neglect. 5 greater than 0.1 neglect. 10 also greater neglect. So neglect. So magnitude means what I can write here, tell. 32 equal to 20 log K minus 20 log omega. Magnitude means omega na. K by j omega magnitude, K by omega. So minus 20 log omega. What is omega value? 0.1. So here it should be 0.1. This will become plus 20. Come this side. Plus 20 if you come this side, what? Minus 20. Minus 20 means 12. 12 equal to 20 log K. So K equal to how much? K equal to 10 power 0.6. Approximately 4. K is approximately 4. Next is take even 6 or 2. Same answer you will get. For example, second case I'll take. 6 at a frequency of 2. What term consider? Tell. I'll write better transfer function here. What is GH? Tell. GH of S equal to K into 1 plus S by 10. S by 2. S by 5. Now second case I'll take. What is the second case we taken? Second case is 6 at omega 2. 6 at omega 2. Below what are the term consider? 20 log of, come on, equal to also neglected. 2 equal neglect. 5 greater neglect. 10 greater neglect. That means magnitude of what? K by j omega. Magnitude of K by j omega. Come on, write 6 equal to 6 or 2 equal to below 20 log K. 20 log K minus 20 log omega. 20 log omega minus na 1 by omega magnitude minus. This is 2. That means 20 log 2 is 6. This will become minus 6. Come other side. 12 equal to 20 log K. K equal to 10 power 0.6. Approximately 4. Next, even take a third case. Same answer you will get. 6 at a frequency of 5. Then also same answer. 20 log K. 20 log magnitude of K. Now tell. So J omega default consider. J omega default consider. Poles and zeros at the origin default consider. Next, 2 consider are neglected. 2 is less than 5. 2 is less than 5. That means consider. That means I can write 1 plus S is called J omega. J omega by 2. 5 equal to not consider. 10 is greater than 5, not consider magnitude. And now get the answer. Same answer will get omega to omega equal to 5. 6 at omega equal to 5. Equal to 20 log K minus 20 log omega minus 20 log omega. Now write dB term for this. Plus 0 na plus. What is the dB term? 20 log root of real square plus imaginary square. 20 log root of real square. Real square means 1 plus imaginary square means omega by 2 whole square. Now omega is 5, substitute. Omega 5 is substitute. Here 5. Here 5. So 5 by 2, 2.5 whole square, 6.25. 6.25 is large or 1 is large? So 6.25 large means one term in the root compulsory neglected because it is approximated plot. Neglected. Neglected. Now get the answer. So what is the answer? Tell. 6 equal to bolo 20 log K minus 20 log 5 plus 20 log 2.5. 20 log 2.5. Now solve. 6 equal to 20 log K minus 20 log 5 by 2.5. 5 by 2.5. 5 by 2.5. 5 by 2.5 means what? 2. 2. So minus 20 log 2 minus 6. Come this side 12. So 12 equal to 20 log K. K equal to 10 power 0.6. Approximately 10 power 0.6. Approximately 4. Next, fourth case. Fourth one. 0 at a frequency of 10. Fourth case. Dekho 0 at a frequency of 10. Solve it, all of you. You'll get the same answer. What term consider? Tell. 20 log. Come on, what are the terms consider? Magnitude of K by J omega fixed. Remain terms you tell. 2 is greater or less than 10 means consider. Less means consider. So 1 plus J omega by 2. Next 5. 5 is what? Less than 10 means consider. So 1 plus J omega by 5. 5. Next 10 is great. 10 equal to not consider. Magnitude. Solve it. You will get the same answer. Same answer you will get. So 0 at 10 equal to 20 log K minus 20 log omega. Write dB term for this. 20 log root of real square plus imaginary square omega by 2 whole square. Next minus 20 log root of real square 1 imaginary square omega by 5 whole square. Now solve this. Come on, omega 10 is substitute. Omega 10. Here 10. Here 10. Here 10. Come on, get the answer. Bolo. So 0 equal to 20 log K. 20 log K minus 20 log of. Come on. Bolo. So 10 plus 20 log of. So here 10 by 2, 5. 5 square, 25. 25 means 1 neglected. Here also 1 is neglected, na? 2 square, 4. 1 small value neglected. Then what is the answer? Plus 20 log of 5, I think. Minus 20 log of 2. Now solve this. Come on, 0 equal to 20 log k minus 20 log, take it common. Then what I will get? 5 into 10 into 5 by 2. This is minus, plus, minus. Okay, right. 10 into minus, I taken common, na? 10 into 2. This both are minus, so 10 into 2 divided by plus means 5. You solve it by calculator. This will become 4. And find it. K is approximately 4. You solve any method, the K value is same. Why I solved this problem means, why we solved this problem means, sometimes that fellow, he never gives this magnitudes. You will give, never, you don't give. Then what happened? There is no option other than taking 0 to 10. So that means knowing a magnitude, one frequency is enough to find the K value. Knowing the magnitude at one frequency is enough to find the K value. So be remember, don't think that always requires starting magnitude, starting frequency. Even magnitude at any frequency we know, we can find the K value. Okay, na? Next problem. Next problem. Find omega 1, omega 3, M1 and M3 and transfer function. Come on, do it. So this is 24.1. This is M1. This is M3. (20.05) minus 20.05 M3 omega 3 omega 1 0 1. Come on, solve it. First find omega 1, next M1, like that. Come on, you find, you try. Completed? M3 minus 12. Come on, write. Come on, get the answer. First select this line. First select this line. Like this. Don't select the first line. Why? Because if you select first line, two unknowns. What are that? Omega 1 also unknown, M1 also unknown. M1 is unknown, omega 1 is unknown. So you don't get the answer. Select the second line. Omega 1 to select up to 8 only. Omega 1 to 8 only select. Don't select even up to 16. Omega 1 to 8 only select. Then get the answer. So calculation for omega 1. Bolo minus 40 equal to M2 0. M2 0. M1 24.1. 24.1 divided by log of at 0. What is the frequency? 8 minus log of at omega at 24.1. What is the frequency? Omega 1. Find the value of omega 1. Find the value of omega 1. Omega 1, I think you will get to 1.9 something you will get. Approximately 2 radians per second you will get. Don't select up to 16. Again, it will become two unknowns. Select up to 8 only. At 8 given magnitude 0 dB. At 8 given magnitude 0 dB. So 0 minus 24.1. At 0, 8. So log 8 minus log omega 1. Then you can get the omega 1. So we got omega 1 is 2. Now select the starting line. Get the value of M1. So find the value of M1. What is the slope? Minus 20. Minus 20 equal to M2. 24.1. M1 is M1 only. Divided by log of at 24.1. What is the frequency? 2. Minus log at M1. What is the frequency? 1. Then get the answer. M1. Log 1 0 and solve for M1. You will get, I think, anybody? What is M1 answer? 30.11, 30.12 approximately, 30.12 dB, I think. 30.12. Next, get the, this is 30.12 or 11 something, 119 or something. Next, get the M3. Next, get M3. So for M3, we can select even omega 1 to 16 or 2 to 16 or even 8 to 16 you can select. The answer is same. Either 2 to 16, 8 to 16, the answer is not changes. For example, 8 to 16 if you take, slope minus 40 equal to M2 is nothing but M3. M1 is nothing but 0 divided by log of at M3, what is the frequency? 16. Minus at 0, what is the frequency? 8. At 0, frequency 8. Now get the value of M3. I think M3 will get minus 12 dB, I think. Minus 12.04 dB, I think. M3 minus 12.04, I think. Correct? Huh? I think correct. M3 magnitude, yeah. Minus 12.04. Next, get the value of omega 3. Next, get the value of omega 3. So what is the slope? This, select this line. So this answer is minus 12.04. Omega 3. Select this line. Slope is minus 20 equal to M3 minus 12.05. minus M1. So minus of minus 12.04 divided by log of omega 3 minus log of 16. Then get the value of omega 3. Get the value of omega 3. Bolo. What is the answer for omega 3? I think 40 change you will get. I think 40.23. I think 40.23 radians per second. Now find the transfer function. Find the transfer function. So g of s h of s equal to g of s h of s equal to k. Initial slope minus 20 means yes. Change in slope you find here. Opposite sign add means minus 20. So that means 1 plus, come on, tell man, 1 plus s by 2. S by 2. Now find here change in slope. So opposite sign plus 40 minus 20 means plus 20. So 1 plus s by 16. Here change in slope minus 20. 1 plus s by 40.23. Now get the k value. So where we know the magnitude? 30.12. You can take any magnitude at any frequency. Same answer you will get. At 1 equal to 20 log magnitude of k by j omega. K by j omega. Come on, bolo answer. 32.12 equal to 20 log k minus 20 log omega. Magnitude means omega. Omega is 1. So 1 means 0. So that means solve for k. K equal to how much? Tell. K is 32, I think. 32.06 you will get. That's all. Next problem. Solved, all of you got it answer? Next problem. Hello?
సార్ బిఫోర్ ప్రాబ్లం లో మాగ్నిట్యూడ్ M2 6 ఎట్లా వచ్చింది సార్? ఇంకా ముందు సార్ 6 మాగ్నిట్యూడ్ 6 M2 ఇది.
Here 6 magnitude is there kada, 6 at 2, 6 at 5.
ఇచ్చారా సార్ అది లేకపోతే మా
They given in the question. Right, next. Right. Next problem. One more thing here. Sometimes they are asking a steady state errors also. They'll give a Bodo plot. They'll ask the steady state error. So just whenever they ask the steady state errors, you just write the transfer function, then find the steady state error. For example, you take this problem. Find the steady state error for unit step input to the given magnitude plot. Find the steady state error to the unit step input. To the given magnitude plot. Come on, solve. 20 తీసుకో. Not required. Come on, do it. What is the answer? Anybody? Slope not required. Slope not required. Come on, do it. One by 11. Very good. See, simply write the transfer function. What is the transfer function? Tell. G of s h of s equal to k by initial slope 0. No poles and zeros at origin. Change in slope we don't know, but negative slopes. Negative slope. Negative slope means compulsory it should be poles. We don't know how many poles. So simply you can write 1 plus s by omega 1 whole power n. N may be 0, n may be 1, n may be 2, n may be 10, or we don't want that. Now find the k value. So 20 at a frequency of 0.1 equal to 20 log k. That's all. So that means k equal to how much? Tell 10. K equal to 10. That means GH becomes what? Assume always unity feedback, either mentioned or not mentioned. Mentioned or not mentioned, always assume unity feedback. Always assume unity feedback in the Bodo plots especially. Always assume unity feedback in the Bodo plot. Assume h of s equal to 1 always. Okay, so g of s equal to what? 10 by 1 plus s by omega 1 whole power n. What is the steady state error formula? A by 1 plus k. A is 1 because A is a unit step input. A1 divided by 1 plus k. K is called numerator constant by denominator. Numerator 10, denominator 1. So answer is 1 by 11. Like this you have to calculate. Okay. This is the type 0 system. Initial slope 0 means type 0. Initial slope minus 20 means what? Type 1. Like this. Come on, solve for this. Get the error for. Get the error. For unit ramp input and unit parabolic input. Steady state error for unit ramp and parabolic. Find for all. Steady state error for unit step. Unit ramp. Come on. And unit parabolic. Come on, do it. Come on, tell the answers. Tell what is the doubt?
సార్ ఇక్కడ మనం యాంప్లిట్యూడ్ ఏ వాల్యూ మనకి తెలియదు కదా సార్, అంటే గెయిన్ వాల్యూ
మీరు ఇచ్చారు కదా 20 amplitude యూనిట్ అని మెన్షన్ నా
యూనిట్. ఓకే, యూనిట్ స్టెప్. ఓకే,
రైట్. నెక్స్ట్ right. So what is the answer? What is the transfer function? Tell. G of s equal to h of s 1 you assume. G of s equal to what? Simply k by s. So K is directly we can take minus 20 into 1 na, so 10 power 1. That means G of S equal to 10 by S. So even if we give like this, then plus 20, it will become plus 20, means 1 here omega 1 if you take 1 plus S by omega 1, either you term right or not, nothing matter. So now this is the transfer function. H of S assume as 1. So now for unit step, this is type 1 system. First for step, type 1, step input is 0, not 0 for step. I told in the steady state error, type is greater. That means steady state error is 0. Next for ramp, type 1, ramp 1, both are same. Get the steady state error. A by K, type 1, ramp also 1. So A by K. A is 1. K is numerator constant by denominator. Denominator is by default 1. So 10 by 1. That means answer is what? 0.1. So unit parabolic. Parabolic means the value is 2. The ramp is 1. Parabolic 2. Type is less. Type is 1. Type is less than infinity. That means steady state error is infinity. That's all. Like this, you have to get the steady state errors. Okay. Next problem. Very good. 0, 10, 0.1 infinity. Many students told correct answer. Next problem. Find the transfer function to the given minimum pay system. Option A, JF by F1. Option B, JF1 by F. Option C, 1 plus JF by F1. Option D, 1 by 1 plus JF by F1. Tell the answer. Here, instead of omega, you given frequency. Instead of omega, you given F. Yes or no? Instead of omega, you given F. Then solve it. So what is the actually here if you give in case omega, this is called omega 1. In case here given omega, in case mentioned here omega, this will become omega 1. Omega 1. Now get the answer. Come on, see, write the G of S, H of S. G of S, H of S equal to, come on, K, initial slope 0. Change in slope is what? Plus 20. Change in slope plus 6 dB for octave equal to 20 dB for decade. 20 dB for decade means plus 20. Actually, in case here given omega 1, what you will write? Tell Plus 20 means I'll write 1 plus s by omega 1 I'll write. So, but what he did, he converted into frequency. So, s replaced by j omega, gh of j omega equal to k into 1 plus j omega by omega 1. Then omega is 2 pi f. gh of j 2 pi f equal to k into 1 plus j 2 pi f by 2 pi f1. 2 pi f1. 2 pi cancelled. Simply I can write gh of jf equal to what I can write k into 1 plus, here also you can put jf in terms of f we are writing, and you can write bolo, writing in terms of frequency, gh of f you can write. So that equal to what I can write jf by f1. Simply whenever they gives here frequency, write jf by f1. jf by omega 1, jf by 2, jf by 4, jf by 10, like that you write. Now find the k value, where we know magnitude 0 dB. 0 dB at a frequency of what? f1. So 0 dB equal to what? So f here f1 equal to not consider. Simply 20 log k. K equal to how much? 10 power 0 means 1. So answer is what? gh equal to 1 plus jf by f1. That's all. jf by f1. This is the answer. ठीक है ना? ठीक है ना? Right, very good. Right. Next, classifications of systems. Minimum pace, non-minimum pace, all pass systems. So this classification we'll discuss. First of all, why everywhere you are writing plus only? Plus, 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 plus everywhere? Because of minimum pace system. The word always find transfer function. They'll mention find transfer function to the given minimum phase system. Bordeaux magnitude plot of minimum phase system they'll mention. Bordeaux magnitude plot of minimum phase system compulsory they'll mention. Minimum, in case minimum phase is not mentioned, minimum phase system, in case minimum phase system not mentioned, to this problem I can write 1 plus s by omega 1. It is also correct. gh equal to, even I can write 1 minus s by omega 1 also I can write. This is also correct because magnitude for both the things, what is the magnitude tell? The magnitude become root of 1 plus omega by omega 1 whole square only, the magnitude. Either plus or not only that, you put here e power plus or minus ks. Here also put e power plus or minus ks. Also the magnitude is same. The magnitude is going to be same. For all these things, the magnitude is same. For all these things, the magnitude is same. There is no change in the magnitude. So that's why they mention always minimum phase system. They'll mention always minimum phase system. Minimum phase system means a system in which all the finite poles, finite zeros, consider only in the left half of the S-plane. A system in which all the finite poles. So that means here it should be considered plus plus only. So put the heading minimum phase system. Minimum phase system. A system in which all the finite poles and finite zeros lies in the left half of the S-plane. A system in which all the finite poles, finite zeros lies in the left half of the S-plane, then it is called MPS, means minimum phase system. Minimum phase system, then it is called minimum phase system. ठीक है ना? A system in which all the finite poles, finite zeros lies in the left of the S-plane, then it is called minimum phase system. Be remember, ठीक है ना? So minimum phase system is a stable system. I'll write MPS. MPS is a stable system. And the GH is stable, not that 1 plus GH. GH should be stable. Directly we can identify, like example. So G of S, we are not talking about closed loop transfer function. We are talking about GH. GH stable means 1 plus GH may or may not stable. 1 plus GH stability given by gain margin and phase margin. Like here I can write S plus 1 by S plus 2, S plus 3. This is the example for minimum phase system. This is the example for minimum phase system. Worst case, consider only one pole at origin. You should not consider more number of poles at origin. Maximum one pole and worst case minimum phase system may be marginal stable. Strictly speak, it should not consider even pole at origin. Worst case I am telling. So maximum one pole at origin is considered. Maximum one pole at origin is considered. One pole at origin is considered for minimum phase system. For MP, not consider more than that. ठीक है ना? Minimum phase system gives the angle of what? P minus Z into minus 90 degrees. Minimum phase system gives the angle of minimum phase system. Gives the angle of P minus Z into minus 90 degrees at omega equal to infinity. At omega infinity, if you calculate angle, that angle is equal to P minus Z into minus 90 only. For example, what is the angle here? Tell P minus Z, you tell. What is the P minus Z? P is 3. Z is 1 into minus 90. P is 2. P2. Z is 1 minus 90. Yes or no? That means 1 into minus 90 means minus 90 degrees. Even if you write pi for this, pi at infinity, calculate, same answer you will get. What is the phase angle for this? Tell how to write phase angle. S plus 1 phase angle is what? Tan inverse omega. Tan in S is called J omega, na? Tan inverse of imaginary part by real part means omega. S plus 2 phase angle tell minus tan inverse of pole na minus. S is called J omega. So omega by 2 minus tan inverse of omega by 3. So now come on, omega value substitute. What is omega? Infinity. 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 Infinity substitute. Come on, bolo. 90 minus 90 minus 90. What is the answer? Minus 90. Same answer you will get. This one. ठीक है ना? Poles and zero location for minimum phase means everything it lies in the what? Left of the S-plane only, like this. Next, second one, all pass system. All pass system. What is all pass system? A system in which all the finite poles, finite zeros lies in a system in which all the finite zeros lies in the right of S-plane. a system in which finite zeros lies in the right of S plane, in the right of S plane, and finite poles lies in the left of S plane, lies in the left of S plane, which are symmetrical about imaginary axis, which are symmetrical about imaginary axis is called alpha system. Symmetrical about imaginary axis is called alpha system. Alpha system is called alpha system. Now come on, this is alpha system. For example, how it will be means like this. Zero right means pole left. So by default, zero right. Don't take pole right system. It can take it, but first priority is zero is right. So this is what. So poles and zeros position in alpha system. Example for alpha system is g of s h of s equal to like s minus 1 by s plus 1, or we can write s square minus 2s plus 2 by s square plus 2s plus 2. So this is the what example for alpha system. So in alpha system magnitude is 1. Alpha system gives the magnitude 1. Alpha system gives magnitude is 1. Gives magnitude equal to 1. And phase varies between plus or minus 180 degrees. It is not fixed, varies between plus or minus 180 degrees. Phase varies. Phase varies between plus or minus 180. This is about alpha system. The pole zero placement in the alpha system is called what? Antisymmetric pole zero pattern. Antisymmetric pole zero pattern. The pole zero placements. The pole zero. The pole zero placements. The pole zero placements in alpha system is called antisymmetric pole zero pattern. Antisymmetric pole zero pattern. Okay, na? Next. So one more thing here, the magnitude should be 1 means even put a pole right, 0 is left, then also magnitude 1 only. That is also correct. But first priority is, be remember, first priority zeros in the right. In case not, just check for magnitude 1. First priority is zeros in the right of S plane. Zeros in the right of S plane. Next, non-minimum phase system. What is the non-minimum phase system? A system in which a system in which one or more finite zeros, one or more finite zeros, or one or more finite poles, one or more finite poles, are both poles and zeros, both poles and zeros, lies in the right of S plane, lies in the right of S plane, then it is called non-minimum phase system. Non-minimum phase system. Then it is called non-minimum phase system. Okay, a system in which one or more finite zeros or one or more finite poles or both poles and zeros lies in the right of S plane, then it is called non-minimum phase system. Okay, na? Then it is called non-minimum phase system. Now, come on, do it. Example, in case example you take, there may be one zero or pole. There may be many poles and zeros in the left-hand side, immaterial. So one or pole is there, then it is called non-minimum phase system. Non-minimum, why they called means right-hand side poles and zeros is there, automatically the angle never becomes zero. In a minimum phase system, if you put omega 0, the angle becomes 0. It becomes very, very small. That's why they put a minimum. Non-minimum, it never becomes 0. So now this is the non-minimum phase system. Example for non-minimum phase system is non-minimum phase system. G of S, H of S equal to, example is like S plus 1, S minus 2, S plus 3, S plus 5. So this is the example for non-minimum phase system. But this can be written as, how can you write this? GHS equal to S plus 1 by S plus 2, S plus 5, S plus 3. S plus 3, S plus 5. Into what I can write? S minus 2. So divide and product with S plus 2. Here S minus 2, S plus 2. Here also S plus 2. Divide and product with S plus 2. Divide and product. Now this is non-minimum phase system. Non-minimum phase system is nothing but, actually this is non-minimum, is nothing but, that only I written like this. This is called minimum phase system. This is called all pass system. So non-minimum phase system is nothing but product of minimum phase and all pass system. Non-minimum phase system is nothing but product of minimum phase and all pass system. Even you can write phase angle for this. What is the phase angle? Pi of non-minimum phase system equal to, product means angles become addition. Pi of minimum phase system plus pi of all pass systems. Pi of all pass systems. Okay. I told MPS only one pole only. We don't consider zeros at origin. Even we don't consider more zeros. MPS means finite pole, finite zero. Forget about poles and zeros at origin. It is stable. At 2 poles you put it, it become unstable at origin. Maximum 1 pole, and worst case MPS is marginal. That's all. Next, one question, one problem. Identify the course ABC. Identify the curves A, B, and C in the given phase plot. In the given phase plot. This is 0 degrees. A, B, C. Minus 90, minus 180, minus 270. Come on, do it. A, B, C. Option A, non-minimum, minimum, all pass. B, minimum, non-minimum, all pass. C, minimum, all pass, non-minimum. D, none. What is the answer? C is correct. This is minimum phase. This is all pass. Unless until add this to, then you don't get minus 270. Now this is non-minimum. So like this, you have to identify minimum, non-minimum, and all pass. You want break or continue? 15 minutes, okay? 15 minutes break. Okay. Mohammed?
Sir.
Tell.
Page number 19, sir.
Huh?
Page number 19.
Tell. 19. Tell.
19. Sir, that maximum of one pole at origin is considered for MPS, na, sir. Sir, the, what about zeros?
Zeros also.
Pole or zero, both.
That's all. But generally we don't consider zero because it become high pass filters. Okay.
Okay, that's.
Next. Venkatesh.
Sir, last page, sir.
Tell. Tell.
Curve A is MPS, sir.
Minimum
Curve A,
angle,
how
na?
it is MPS, sir?
Minimum angle or maximum angle? Minus 90.
Okay, sir.
Minimum phase means it should be our lowest angle compared to all. Muhammad, already okay na? Abdul.
సార్ ఇది ఇప్పుడు మాక్సిమం ఫేజ్ సిస్టమ్ ఆల్ పాస్ లో ఏది అంటే ఏ ఫేజ్ సిస్టమ్ అని చేస్తారు అంటే పోల్స్ కి ఫైనల్ జీరోస్ మనం క్యాలిక్యులేట్ చేయాలంటే
ఏది ఫైనల్ పోల్ వాట్ యు ఆర్ ఆస్కింగ్ టెల్ దిస్ ఇస్ ఓన్లీ నాట్ టెల్
అది కాదు సార్ కర్వ్స్ లో ఈ కర్వ్స్ ఇప్పుడు డయాగ్రామ్ లాస్ట్
టెల్
ఇప్పుడు యాంగిల్స్
minimum lowest angle if you add minimum and alpha you should get the non minimum.
అంటే
add any two you should get the maximum angle, that is called non minimum. Use this formula na, use this formula.
అర్థమైంది సార్, నేను అనట్లేదు. ఇప్పుడు మనం క్యాల్కులేషన్ చేసేటప్పుడు ఇప్పుడు మన రియల్ టైమ్ లో క్యాల్కులేషన్ అప్పుడు ఏది బెస్ట్ అనేసి ఆల్ పాస్
That's all. What is there, man? Minimum phase best because it is stable system.
Stable system. All pass is non-stable, unstable.
It may or may not because poles may also lies right.
Okay.
Okay, take the break. Take 15 minutes break. Okay, next. ठीक है ना? Next. Okay, next. Next one. Calculations of gain margin and face margin. Calculations of stability condition, and first we'll discuss gain margin, face margin. Stability conditions. Stability conditions. Stability conditions. Stability conditions. Okay. So the stability conditions are to find closed loop stability. Stability conditions are to find the closed loop system stability. So stability conditions are to find the closed loop system stability. Stability conditions are to find closed loop system stability. ठीक है ना? So how to find closed loop system stability? Closed loop system stability given by characteristic equation. Closed loop system stability closed loop system stability is given by characteristic equation. Characteristic equation. Closed loop system stability is given by characteristic equation. So that is 1 plus g of s h of s equal to 0. 1 plus g of s h of s equal to 0. Now come on. What is g of s h of s here? S replaced by j omega. Then characteristic equation is 1 plus g of j omega h of j omega equal to 0. Then g of j omega h of j omega equal to -1 plus j0. -1 plus j0. Now write the magnitude. This gives the magnitude and phase. Now write the magnitude. So magnitude of g of j omega h of j omega is equal to 1. Magnitude equal to 1. This is in linear. Now write in dB, magnitude in dB. That equal to 20 log 1. That equal to 0 dB. So here they defined in dB is 0, linear is 1. They defined here gain crossover frequency omega gc. That is called gain crossover frequency. They defined gain crossover frequency. Next one. Write the phase angle. Write the phase. Angle of G of J omega. Angle of -1 by J. That equal to what? Minus 180 degrees. Don't take plus 180. We have to take negative angles only because control systems are low pass filter. Mainly control systems, low pass filter, more poles are there na, compared to 0. More poles. That's why minus 180. Here defined phase crossover frequency. This is omega PC. So what is the gain crossover frequency? The frequency at which magnitude equal to 1 or 0 dB is called gain crossover frequency. Gain crossover frequency. The frequency at which magnitude equal to 1, magnitude equal to 1 or 0 dB is called gain crossover frequency. What is phase crossover frequency? The frequency at which phase angle equal to minus 180. Phase angle. Ready? 1 minute. Right, the frequency at which phase angle equal to minus 180 degrees. The frequency at which the phase angle equal to minus 180. Phase angle minus 180 is called phase crossover. Magnitude equal to 1 or 0 dB is called gain crossover frequency. The frequency at which phase angle equal to minus 180 degrees is called phase crossover frequency. Next, gain margin. Simply GM. Inverse of magnitude, it is inverse of magnitude at omega PC. Gain margin equal to 1 by magnitude of this is in linear. In dB is minus 20 log, apply 20 log, that's all, minus 20 log of g of j omega h of j omega at omega equal to omega PC. This is in dB. This is in linear. Next one. This is the gain margin. So, okay. Even we can, there is another definition for gain margin in some books they given. It is a factor of system gain. Gain margin is a factor. Gain margin is a factor of system gain. Is increased to drive the system to drive gain margin factor of system gain is increased to drive the system to the verge of instability. Verge of instability means simply it is marginal stable. Instability means it is a marginal stable. Okay, that means as the K go on increase, what happens? It will come. I'll take one problem, I will explain. Okay. Gain margin, factor of system gain only. Gain margin is K only. So it is increased. As go on increase, at some cases it becomes the marginal stable. Next, phase margin. Phase margin. What is the phase margin? Tell. It is the additional phase lag. It is the additional phase lag. It is the additional phase lag required to add to the system. It is the additional phase lag required to add to the system to drive verge of instability. What is the formula? Verge of instability means marginal stable. What is the formula for phase margin? 180 plus angle of g omega is the formula for phase margin. It is a formula for phase margin. Okay. So next, when the system is stable. When the system is stable. When the system is stable. Simple conclusion is, listen, no need to calculate gain. If you ask either system stable or not, it is not required to calculate. Blindly we can tell the answer. Simply, if omega PC greater than omega GC, blindly we can say closed loop system stable. Why? Because in this case, gain margin default become positive in dB, greater than 1 in linear. And phase margin is positive. if omega PC equal to omega GC, then closed loop system marginal stable. Then gain margin equal to 0 in dB, equal to 1 in linear. Why I am telling linear scale means I don't discuss again gain margin, phase margin definitions, especially in the Nyquist and polar plots. Just directly I'll write the gain margins and phase definitions should be remembered. Next, if omega PC less than omega GC, closed loop system unstable. Why? Because even if we calculate, gain margin becomes negative here, no doubt. If we calculate gain margin negative in dB, less than 1 in linear, and phase margin also negative. So if these are the conditions for stability, but these are valid for only minimum phase system. The conditions valid only for minimum phase system. It is not valid for non-minimum systems as well as remain system. It is valid for only minimum phase. That means the GH, whatever the GH is there, that should consist only finite poles, finite zeros. That also lies in the left. Maximum only one pole at origin is allowed. Okay, otherwise it is not considered. We don't calculate the stability by using gain margin and phase margin if it is not a minimum phase system. The given system is not a minimum phase system. We don't calculate gain margin, phase margin. Don't calculate. Okay, na? It is valid for only minimum phase system. Border plots drawn for only minimum phase systems only. Generally, if you want to draw, we can draw a border plot. What is the difference? Magnitude plot is same, but the phase plot is different. Phase plot is different. Magnitude plot is same. Phase plot is different. So we can draw, but we cannot write the stability. Stability cannot write for non-minimum phase system. Stability want to find for non-minimum phase system, then you have to go by Nyquist plots. It will come how we have to find it. Border plots gives the stability of only minimum phase systems. That's all. Next one. Next. Note on the problem. Identify the stability and gain margin, phase margin. Minus 180 degrees. Come on, find it either stable or not. Come on. First identify the stability. Identify the stability. Is it stable or unstable? Stable. Stable. Right. Right. Listen. See, first here, the frequency at which magnitude is 0 is called gain crossover frequency. The frequency at which phase angle is minus 180 is called phase crossover frequency. Take the projections one and another. Take the projections one and another. So just take the projections. So omega PC greater than what? Omega GC. Omega PC greater than omega GC. That means closed loop system 100% it is a stable system. Closed loop system is stable system. In case, for example, they give this magnitude. In the exam, for example, they'll give this magnitude. In case this is minus 20 dB. This is the phase angle of minus 150 degrees. Now find the gain margin and phase margin. Now find the gain margin and phase margin. Come on. Find the gain margin and phase margin. Non-minimum phase system, who told it is stable? Aya? Kya pagal aya? Non-minimum phase system may be stable, may be unstable. That also for GH, not 1 plus GH. Now we are finding 1 plus GH stability. I told very clearly, you are not listening. GH stability we can identify by looking transfer function. For example, S plus 1 by S plus 2. S plus 3 there, I can say stable. Can you say 1 plus GH stability here? You have to find closed loop transfer function and roots. That 1 plus GH stability we are finding by using Border plot. Listen, put the mind. Non-minimum phase system, we don't draw Border plot at all. Non-minimum phase system stability will find by using Nyquist plots. Non-minimum phase system always stable under. Non-minimum, already I told one definition, you read at least, read the definition. What is the definition of non-minimum? Pole right in, clearly it is there. Are you there in the class or sleeping? What is this? Pole right, how it is stable? Listen class first and read 2-3 times, then you will get. Sorry, listen. Find the gain margin. What is the gain margin here? What is the formula for gain margin? Gain margin equal to bolo, minus 20 log of magnitude of GH of J omega at omega equal to omega PC. This is the formula. But here, this 20 log, whatever is there, this 20 log, this portion is nothing but simply magnitude in dB. How will write magnitude in dB? By applying 20 log, na? So that means the formula for gain margin is Simply minus of magnitude in dB at omega equal to omega PC. Gain margin equal to minus of magnitude in dB at omega equal to omega PC. Now tell at omega PC what is the magnitude, tell. At omega PC what is the magnitude? This is omega PC, what is the magnitude? I have minus 20. Magnitude in dB at omega PC equal to minus 20 dB. Now tell gain margin. Minus of minus 20 dB. That equal to what? Plus 20 dB. Gain margin equal to plus 20 dB. That's all. Now find the phase margin. Pi at omega GC, how much? At omega GC, what is the pi? Minus 150. Pi at omega GC is minus 150. Pi at omega GC is minus 150. Minus 150. Now find phase margin. What is the formula? What is the gain margin? What is the meaning of gain margin 20 dB? What is the definition of gain margin? Gain margin? It is the factor of system gain and K. It is the factor of system gain K. Go on increase. That only is the definition. Go on increase. Factor of system gain K increased to become system marginal stable. K increases, what happened in the magnitude plot? K increases, what happened in the magnitude plot? K increase means plot shifted upward. Total plot shift upward. If you shift upward, you will get like this. If a total plot shift upward, you will get like this. Once you get like this, this will become omega GC. This will become omega PC. Omega PC equal to omega GC. System what happened? Marginal stable. If I shift to 20 dB upward, 20 dB upward, if I shift it, it will become marginal stable. In case you are increasing more than 20 dB, the system become unstable. Here we will say 20 dB. Linear scale, we can say K greater than 0, less than, for example, 20 dB, we want it to convert into linear scale. Then that value, for example, K may be greater than 0, less than some 100. 100 means 20 log 100, 40. Here gain margin 40 dB, K greater than 0, less than 100, both are same. Gain margin 40, nothing but K value is 0 to infinity, 0 to 100. Because 20 log 100, how much? 40, both are same. Here we are telling in dB, whereas in RH criteria, root locus, we are telling in terms of K. So 20 dB means 20 dB you have to shift upward. How can shift plot upward? Gain should be increased. That is the definition. Gain margin is nothing but increasing the system gain so that it become marginal stable. So it is a range from marginal stability to 20 dB and 0 to 20 dB stable. More than that unstable, that's all. So next phase margin. It is the additional phase lag you have to add. And how much we have to add here? Then it become marginal stable. How much if you add it? So that system become marginal stable. How much it should be added? What is the formula? 180 plus pi at omega GC. So that means 180 minus 150. So how much you are getting? Plus 30. That means if minus 30 degrees, if you are lagging means negative angle. Lagging means negative angle. Phase margin plus 30 means you have to add a minus 30 degrees. If you add minus 30, what happened? Tell here. For example, this point here. If you add minus 30, it becomes what? Minus 180. And this point will come here. The plot will go like this. This point will come here. Then what happened? Omega GC equal to omega PC. Again, system becomes the what? Marginal stable. So negative phase lag, additional phase lag we require to add to the system. So add minus 30 degrees, it is going to become unstable. That's all. That is the definition of gain margins and phase margin. That and all secondary. They are giving the plot, they are asking, find the gain margin, phase margin. So like this, you have to calculate gain margin and phase margin. Observe the magnitude at omega PC minus 20. Then gain margin. Observe the phase angle at omega GC. Observe the phase angle at omega GC. Then get the phase margin. Both are positive. Closed loop system stable. This is also positive. This is also positive. Closed loop system stable. That's all. ठीक है ना? ठीक है? Magnitude minus 20. Gain margin opposite minus of magnitude na minus become plus. Next problem. Find the K value. Find the K value to become the system marginal stable. Find the K value to become the system marginal stable. Come on, do it. Find the K value to become the system marginal stable. Assume the transfer function to the given plot is GH equal to 10 by S into S tau 1 plus 1, S tau 2 plus 2. S tau 2 plus 1. The transfer function to the given plot is 10 by S into S tau 1 plus 1, S tau 2 plus 1. Then when I taken 10 by S tau 1 plus 1, S tau 2 plus 1, I got the gain margin 20 dB and phase margin is 30 degrees. Transfer function for plot. This is given in the question, not we are finding from this. Transfer function for plot. Plot is GH equal to 10 by. Find gain margin and phase margin. It's a question. This is the question. This is the problem. Here, this is the problem. Come on. Find the K value to become the marginal stable. The transfer function to the given system is 10 by S into S tau 1 plus S tau 2. Come on, S tau 2 plus 1. What is the physical mean? Kya pagal ho gaya? Kya bhaiya? What is the physical mean? Tell stability condition. That's all, na. Range of K here in dB. Range of K in dB is where? What is the difference? You tell. You tell what is the significance. You tell, man. It is a stability condition. In that range only it gives the what? Bounded oscillations, man. In that range only we'll get the bounded oscillation, so that what happens, system is going to be stable. More than that is unstable. When you are asking the question, you should think, na. Whatever you want, you should not ask, na. Tell. Non-minimum phase system you asked. Non-minimum phase system here very clearly is there, na. You tell. You tell here clearly is there or not, you tell, man. Pole right side, how it is stable, tell. Again you are asking same, no? That's why you think twice. Okay? Right. So now listen. So here you have to find the what? K value to become the system marginal stable. Listen. Listen. Listen, all of you listen. If you listen, then only you will get it. Listen. So we have to find the K value. And they give this Magnitude here. What is the magnitude here? Minus 20. What is the phase angle here? This given in the question. We are not taking a, this is given. This is the question. This is the question. They'll give like this. They'll give like this. And they will ask the K value to become marginal stable, K value to become gain margin 30 dB, K value to become gain margin is 10 dB, 5 dB, like that questions they will ask. So how to find it? Listen. First step here, when the system marginal stable. For marginal stability, what is the condition? Tell omega PC must be equal to omega GC. Then only system is marginal stable. That means at omega PC, omega GC should be exist. At omega PC, omega GC should be exist. Omega GC should be exist. Listen, then only can understand. Otherwise, you will ask again doubts. Listen. At omega PC, omega GC should be exist. This is omega PC. Here we want omega GC. Here we want omega GC. Yes or no? Here we want omega GC. Omega GC. So now, if want omega GC here at this point, what you have to do? Tell this plot should be shifted upward. How much upward it should shift? I need to get here omega because omega PC should be equal to omega GC. Omega PC equal to omega GC. That means at this point we should get the omega GC. At this point we should get the omega GC. That means this total plot I need to shift upward. How much upward I need to shift? Tell how much upward? Come on. How much upward I need to shift? Okay, how much it should be increased? How much up it should be shifted? 20 dB up it should be shifted. Correct, very good. 20 dB you have to shift upward. So 20 dB we shift upward. Then upward means positive sign. Downwards means negative sign because upward K should be more than 1. So 20 plus 20 dB. dB equal to 20 log K. Shift upward equal to plus 20 dB. Plus 20 dB. Upward means positive sign. So plus 20 log K. Or simply 20 log K. 20 cancel. Then K equal to how much? Tell 10. K equal to 10. K equal to 10 power 1. Yes or no? 20 dB equal to 20 log K. Shift is nothing but 20 log K. Na? Shift is nothing but 20 log K. So shift to plus 20 equal to 20 log K. K equal to 10. That means what is G of S, H of S till now? Come on. So this value should be product in the numerator. That means 10 into 10 divided by S into S tau 1 plus 1, S tau 2 plus 1. Then the system becomes the what? Marginal stable. Like this you have to find it. Then the system. Got it, na? Got it or not? Right. Okay. So this plot, if we shift to 20 dB upward, then it will become the what? This is the transfer function for what? Marginal stable. This is the transfer function for marginal stable. So that means if we take 100 in the above transfer function, the system becomes the what? Marginal stable. That is the meaning. Next, same thing. One more question. Solve this. Okay, one more question. Find the K value to get the gain margin equal to 10 dB. Come on. Find the K value to get the gain margin equal to plus 10 dB. Come on. Solve it. Tell the answer. Come on, Guruji, come on. Anybody answer? Find the K value to get the gain margin equal to 10 dB. Anybody? $31.6. Write it. Come on, get the answer. So what happened here? 10 dB want. So gain margin equal to plus 10 dB we want it. Gain margin equal to plus 10 dB. What is the formula for gain margin? Tell minus of magnitude in dB at omega PC. At omega PC. Then plus 10 equal to minus of magnitude in dB at omega PC. At omega PC. So what is the magnitude at omega PC? Tell magnitude in dB at omega PC equal to how much? Tell minus 10 dB. So that means at omega PC required minus 10 dB. At omega PC required magnitude is minus 10 dB. Minus 10 dB. At omega PC required magnitude is minus 10 dB. So, but how much it is exist? At omega PC, how much available? Minus 20. So, but available magnitude at omega PC is, available magnitude at omega PC is bolo minus 20 dB. And the plot, how much we required? Minus 10 only. That means I need here minus 10. This is the minus 10. I need minus 10 only. But how much it is there? Minus 10. That means how much up I need to shift? How much up I need to shift? Plus 10 dB. So plus 10 dB, you have to shift upward. So to get gain margin 10 dB, to get gain margin plus 10 dB, the magnitude plot shift upward by 10 dB. Shift upward by plus 10 dB. Okay, na? Plus 10 dB. So now what is the answer? Tell plus 10 equal to 20 log K. K equal to how much? 10 power 0.5. Na? What is the answer? I think 3.16. 3.16. Now write the GH. What is the GH? Tell GH equal to 10 into 3.16 divided by S into S tau 1 plus 1 S tau 2 plus 1. That's it. Okay, na? I hope you understood. Next, one more problem. Next problem. Find the K value. This is the last problem on gain margin. Next one problem will solve on phase margin after this. Plus 30 dB you tell. Come on. Solve this. Plus 30 dB. I want gain margin plus 30. Come on, Guruji. Come on. Jaldi karo. Point 316. Very good. Very good. 0.316. See here, we want gain margin equal to bolo plus 30 dB. So gain margin is what? Minus of magnitude, na? So that means here. So this is what? Plus 30. Then magnitude is what? Minus 30. So at omega PEC required minus 30 dB. But available magnitude minus 20. To get the minus plus 30 dB, gain margin plus 30. What you have to do, Guruji? The magnitude plot shift downward. Now minus 30 I want. Means here. This I want. That means I need to shift down by minus 10. I need to shift down by minus 10. So down by minus 10. Shift to downward, not upward. Then bolo minus 10 equal to 20 lakh. K equal to 10 power minus 0.5. I think 0.316. ठीक है point. ठीक है ना. Next, one more problem. Right. Find the K value to get the phase margin equal to 20 degrees. 20 degrees. 1 minute, I'll adjust this. We require to adjust the plot. 1 minute. Find the K value to get the phase margin equal to 20 degrees. One minute, Bhaiya. Come on, do it. Come on, Guruji, come on. What is the answer? Anybody, Guruji? Come on. Multiply by 0.316. Is it correct? 0.316. Huh? I don't think, man. Do it correct. Completed? Right. See, listen here. We want phase margin equal to how much we want it? 20 degrees you want. What is the formula for phase margin? Phase margin equal to 180 plus pi at omega GC. Pi at omega GC. So 20 degrees equal to 180 plus pi at omega GC. Pi at omega GC. So what is pi at omega GC? Tell. Pi at omega GC equal to how much? Minus 160. So at omega GC required minus 160 degrees. At omega GC, listen bhaiya, listen, then you will understand. At omega GC required minus 160 degrees. Required minus 160 degrees. At omega GC required minus 160 degrees. So that means what? Here minus 160 degrees. At minus 160 degrees, what happened? We required omega GC. We required omega GC. At minus 160 degrees required omega GC. Here required omega GC. See, phase plot is independent of K. Whatever the question they ask, either gain margin or phase margin, you have to shift to only magnitude plot. You have to shift to only magnitude plot. So at omega GC required minus 160 degrees. So that means here minus 160 is there. Here we need omega GC. Or I can write at minus 160 required omega GC. At minus 160 degrees required omega GC. Omega GC. To get omega GC at minus 160, to get omega GC at minus 160 degrees, the magnitude plot shifted upward by the magnitude plot shifted upward by how much I need to shift upward? Because I need omega GC at minus 160 na. How much up I need to shift? Plus 10 dB upward I need to shift. So shifted upward by plus 10 dB. So plus 10 equal to 20 log K. Got it now? So K equal to 10 power 0.5. So that means what? 3.16. Then GH equal to 10 into 3.16 by S into S tau 1 plus 1, S tau 2 plus 1. That's all. Okay, na? I hope you got it. Just observe what is there here. See, you calculate this first. Phase margin 20. Phase margin 20 means what is pi at omega GC? Minus 160. At minus 160 degrees, we are not having omega GC. At minus 160 degrees, we required omega GC. That means this plot should be shifted upward. Some amount you have to shift upward. How much amount? 10 dB. So 10 equal to 20 log K. Because at minus 160, I need omega GC. That means total plot shifted upward by 10 dB. 10 dB, 10 equal to 20 log K. K equal to 3.16. You will get it answer. Okay? Next one. Just at that angle, how much up should be shifted to get the omega GC, you think it. Okay, na? Okay. Right, next one. Next, complex border plots. Complex border plots. Last topic in this chapter. Complex border plots. Complex border plots. See, actually, it is not in syllabus. Complex border plots is not in syllabus. So, sorry, okay, we'll complete this chapter first. This complex border plots completes, na? The chapter will close. And complex border plots is similar to border plots only. We'll complete this chapter. Okay. Right. What is the complex border plots? Listen. So here, still now, we studied only Boda plots for what? Real poles and real zeros only. S tau 1 plus 1, S tau 2 plus 1, like that only we taken. So next, complex Boda plots means for complex poles. The poles like this complex or complex zeros. Then how to draw the Boda plot? That we'll discuss it. So what is the transfer function? First, n complex poles. N complex poles. So G of S, H of S equal to omega n square by S square plus 2 zeta omega ns omega n square whole power n. So actually the same transfer function we taken for open loop transfer function. This is taken for open loop transfer function. Okay. But this we have to convert into time constant form. Convert into time constant form. So how to convert time constant form? Second order system means, listen, divide with omega n square. Numerator and denominator divide with omega n square. Till now, there is no single question in the gate on this topic. Only IES once asked one objective bit. Just a brief idea I will give. It is not that much important. But you should know, if any question comes, you should be able to answer. So divide with omega n square. This is 1. Here also 1. 2 zeta by omega n into S plus S square by omega n square. S square by omega n square. Okay, na? So this is the what? Like time constant form. So here omega n is called corner frequency. Omega n is called corner frequency. For second order system, corner frequency is omega n. This only asked once. They given a function like this in the IES. S by 3 plus S square by 9. Like this term they given. They asked corner frequencies are. So that omega n is called corner frequency. And then slopes and phase angles. Listen here. So we no need to here derive the what? Slopes and phase angles like first order system. I directly write the slopes and phase angles because we don't require. So here stable, here slope, here phase angle. Below corner frequency means below omega n. Slope is 0. Complex means single pole or two poles. 2 poles. Complex means 2 poles. 2 poles means what is the slope tell? Above corner frequency. Single pole minus 20. 2 poles means minus 40 n. 0 degrees. Minus 180 degrees n. This is the what? Slope and phase angle. Next, draw the Bode plot for this. Below corner frequency 0 dB. Above corner frequency minus 40 and minus 180. Just to double because it is second order system, slopes and phase angles becomes the double. Slopes and phase angle becomes the double. That is the only difference, real and complex. Now if you draw the Bode plot here, if you draw the Bode plot, this is omega. This is omega n. Below corner frequency 0. Above corner frequency minus 40 n. Draw with minus 40. Next phase plot you draw. Take the projections of corner frequencies. Next, what is the phase angle? Minus 180 degrees. This is the phase plot. This is what? Approximated, asymptotic plot. One more thing here, you should know how to write the magnitude and phase this G of S, H of S. Write the magnitude and phase for G of S, H of S. Come on. Come on. Write the magnitude. Write the magnitude and phase for G of S, H of S. Write the magnitude and phase for G of S, H of S. Come on. S replaced by J omega. GH of J omega equal to 1 by 1 plus S replaced by J omega. What I will get here? J omega 2 zeta by omega n minus omega square by omega n square whole power here. Now get the answer. What is the real and imaginary part here? This can be written as, because some people don't know how to write magnitude, that's why I'm discussing. 1 by 1 minus omega by omega n whole square. This is the real part, plus J 2 zeta into omega by omega n is imaginary part. Whole power here. Now write the magnitude. What is the magnitude? 1 by root of real square plus imaginary square. What is the real square? 1 minus omega by omega n square whole square plus 2 zeta omega by omega n omega whole square. This is whole power. This is the magnitude. Like this, you have to write the magnitude for the complex poles. In dB you want, you apply 20 log to this. 20 log to this total top. Write the phase angle. What is the phase tell? Phase. This is the real, this is imaginary. So minus n tan inverse of imaginary part by real part. 2 zeta omega by omega divided by 1 minus omega by omega n whole. So this is the what? Phase angle. So like this, you have to write the what? Magnitude and phase for the what? Complex poles and complex zeros. This is the complex pole. Be remember this, how to write the magnitude and phase for the complex poles and complex. Complex zero means opposites. Just this is for complex poles. Okay. And one more thing here, sometimes they are asking question on correction, M correction. Correction in the complex Bodeplars or errors. Error in the complex Bodeplars depends on, they will ask. Errors in the complex Bodeplars depends on. See, listen 1 minute here. This is asymptotic. Exact you want, this is called exact magnitude. This is called actual magnitude. This is called actual. This is called actual. This is called actual. So for example, correction at corner frequency, they are asking. Correction at omega equal to omega n. What is the answer, anybody? You just substitute omega equal to omega n here. First you substitute here omega equal to omega n. If you substitute omega equal to omega n, this is 1 minus 1, 0. Here also cancel. That means what you are getting, tell? 1 by 2 zeta whole power n. Yes or no? Or what I can write? 20 log of omega equal to omega n. This is 0, this is 1. That means 1 by root 2 square cancel. That means 1 by 2 zeta whole power n. That means correction at corner frequency is minus 20 n log of 2 zeta. correction at corner frequency is minus 20n log of 2 zeta. So correction at corner frequency depends on zeta and the magnitude plot. Pi you tell, pi correction at corner frequency you tell. Pi correction at corner frequency. Omega equal to omega n. So how much tell? You substitute omega equal to omega n. 1 minus 1, 0. 0 means some value by 0, infinity. Infinity means what I will get? 90 degrees, na? Tan inverse infinity 90. That means minus 90. So what is the statement means? The correction at corner frequency in the magnitude plot depends on zeta. Phase plot is constant. The correction at corner frequency depends on zeta. Zeta in magnitude plot, in the magnitude plot. Whereas in the phase plot, it is constant. Whereas in the phase plot, it is constant. It is independent. You can say it is independent. It is constant. That is minus 90. Other than corner frequencies, correction depends on zeta and omega. Depends on zeta and omega. So other than corner frequency means all these terms will be there. Na? That's why it depends on zeta and omega. Here also depends on zeta omega. At corner frequency depends on zeta as well as minus 90. And this statement and how to find corner frequency, these two remember, it is more than sufficient. Okay, this is about the n complex. This is about the what? N complex. Today I will discuss root locus volume and questions. Okay. Right, next. N complex zeros. First listen. What I will discuss everything. Listen. Most of the students, when syllabus will complete, either teach or not, just complete the syllabus like that. There's some students. So write S square plus different students, different opinions. Some students are teach slowly, some students are teach fast, some students are this, that. We know it, how to teach. We are teaching from 2002. What to teach, what to not to teach, how to teach, we know. We should listen, we should learn the subject. So divide with omega n square. G of s, h of s equal to. Divide with omega n square. So what I will get? 1 plus. Do the homework this. Same thing, opposite sign. Just I will write the term. So what is the term? Tell standard form means time constant form. Divide with omega n square. 1 plus 2 zeta by omega n s plus s square by omega n square. So this is the standard form. You remember this enough. The remain procedure, everything same, just opposite side. So omega n is corner frequency. Omega n is corner frequency. Some students asking take up to 9 o'clock. Some students take 7 o'clock. Some students close are enough. Different students, different way. If you tell, what master will do? Below corner frequency 0, phase angle 0. Above corner frequency plus 40n. Here positive, slope become positive. Phase angle also becomes positive, plus 180 degrees here. Okay? Right. This is magnitude only, na? Magnitude at corner frequency. We written already magnitude. Substitute omega equal to omega n. Here you will get the answer. You substitute omega equal to omega n. This is 1 na? 1 minus 1, 0. This will be that only I written here. This is the magnitude at corner frequency. This is corner frequency only. Omega equal to omega n is corner frequency. Just substitute here omega equal to omega n. You will get the answer. Okay. Now note on the problem. Two problems will solve so that the chapter will close. Draw the Bode plot. Draw the Bode plot. G of s, h of s equal to s square into 1 plus s by 20 plus s square by 100 divided by. There is no difference in drawing the plot. Same procedure. S by 3 plus s square by 9 whole power 3. 1 plus s by 20 whole power 4. Come on, draw the Bode plot. Up to what time you want class, you tell. Up to 9 you want. 7, 7, 7, 9, 7, 7. Some people, most of them 7 they are asking. First I'll close this chapter. Then I'll discuss the root locus. After that we'll decide either continue, we'll start Nyquist and polar plot, or Nyquist and polar it is there in the syllabus. That is also very important. So we'll see. After completion of this, we'll decide either close by 7 or 9 or okay. I can take at up to whatever the time you want, I can take. For me, no problem. Okay, write it. First, draw the plot. What are the corner frequencies you tell here? Come on. This is 100, na? This is called omega n square. Omega n square equal to 100. Omega n equal to 10 radians per second. This is omega n. Find zeta also. 2 zeta by omega n. Standard form, remember, na? This is the standard form. This is standard form. This is not standard form. Just to, in case if we forget this, we know this equation. Na? We know complex pole equation. Na? This is complex pole equation. We know omega n square by s square. This he knows. So from this again you obtained it. Divide with omega n square, automatically this standard complex pole you will get. This is standard form. Once you will get a standard form, then you can find zeta and omega n values. So if you remove the numerator, then it will become complex zeros. So zeta, 2 zeta by omega n equal to 1 by 20. What is zeta value? Omega n is how much? 10. Then zeta you find 0.25. Next year, omega n square equal to what? 3. Omega n square equal to 9. Then what is omega n? 3. Radian per second. 2 zeta omega n equal to how much? 1 by 3. Omega n is 3. 3 cancel. So what is zeta? Like that. Yeah. Now draw the Bode plot. First you have to calculate what? M initial. So corner frequency you tell. What are the corner frequencies? 3, 10, this is 3, this is 10, this is 20. These are corner frequencies. 3, 10, 20. Come on now. Come on, Guruji. Magnitude in dB. M initial calculate. M where you have to calculate 0.1. Now first corner frequency 3 means calculate at 0.1. That equal to 20 log. What terms consider? Here K is 1. So that means only S square consider because 3 equal to neglected. What is the 3 now? Oh, sorry. Calculate magnitude now. So how to calculate? You have to calculate K. K is 1 plus 20 log of poles and zeros at origin. M initial, remember na? 20 log K plus 20 log of magnitude of poles and zeros at origin. That means magnitude means omega square. What is the answer? 20 log 1, 0. So what is the magnitude? This will become 40 log omega. Omega is what? 0.1. Then how much? Minus 40 dB. So at 0.1 start at minus 40. At 0.1 start at minus 40. Come on, do it. This is omega. 0.1 start minus 40. Don't write 0 dB. Otherwise, you have to find again at what frequency it crosses. Next corner frequency is 3. This is 3. Next corner frequency 10. Next corner frequency 20. Come on, do it. So now, starts at minus 40. Draw, what is the initial slope? Initial slope is 2 zeros. 2 zeros means plus 40. So draw with plus 40 up to 3. This is plus 40. Next at 3, what are there? At 3 complex poles. At 3, we are having 3 complex poles. 3 complex poles. 3 complex. Each complex pole is minus 40. That means minus 120. Minus 120 plus 40 become, add now, we should add now, minus 120 plus 40, minus 80. You want to minus 80. Okay, na? Minus 80. Next, at 10, what are there? But how to identify at 3 real or complex means there is the only difference between real and complex is taking 40 multiples 1. The second one is you have to represent the zeta value. At a corner frequency 3, what is zeta? 0.5. If you write zeta, that indicates at that corner frequency you have to consider the what? Complex poles and complex zeros. At that corner frequency you have to consider the complex poles, complex zeros. Next at 10, what happened? At 10, what are there? 4 complex zeros. 4 complex zeros. So 4 into 40. That means plus 160. Plus 160. So plus 160 minus 80 become plus 80. Want you draw like this or you draw like this, not a matter. Are you able to write correct slope or not? That is important. So plus 80. Plus 80. Now at 20, what are there? At 20, what are there? At 20, only 4 poles. 4 poles means minus 80. Real poles. Real poles, na? This is the real pole. Minus 80. Minus 80 plus 80 become 0. That's all. Next, draw the phase plot. Draw the phase plot. Phase plot just convert the slopes into phase angle. Phase plot just convert the slopes into phase angle. Plus 40 means plus 180. Project the corner frequencies. Project the corner frequencies. Plus 40 means plus 180. Minus 80 means minus 360. Minus 360. Next, plus 80 means plus 80 means plus 360. Plus 360. Next, minus 80 means minus 360. Sorry, 0, na? This is 0. So 0 means 0. Select the midpoint, draw a smooth curve. Midpoint. Midpoint. Already I told it, Bodo plot starting. Many students might have forget this. Calculating initial magnitude and all that. Right. This is the plot. This is drawing the border plot. Okay. Next, last problem. In border plots, last problem. Find a transfer function. But they are not asking, but you should know now. It is the same thing only, no difference at all. Taking minus 40, minus 180, minus 40 multiples, that's all. From magnitude plot only, we'll draw the phase plot. Okay. Even finding transfer function also same procedure. Come on, do it. You try to find, come on. Solve this problem, all of you. Do it. Point 1. Come on, find the transfer function. 4.7, 10.4, 50. This is plus 40, plus 80 you take. This is minus 120 you take, no problem. This you take it plus 60. Come on, find the transfer function. Come on, Guruji, come on, jaldi karo. Border plot, one question will come at 2 marks. All the stabilities, minimum 4 marks. Come on, do it. G of S, H of S, you find. Okay. Minus 40. Minus 40 means what? S square. Now find change in slopes. What is change in slope here? So opposite sign add means plus 120. Plus 120 means 3 complex, plus means zeros, 3 complex zeros. How to write complex zeros? 1 plus 2 zeta given na 0.7. Divided by omega n called corner frequency 4, yes. Plus S square by omega n square means 4 square. Whole power 3. That's all. Next, find here change in slope. Opposite sign add. Minus 200. Minus 200 means complex pole. Divided by 40 karo. Divided by 40. Complex means divided by 40. 40 multiples. 5 complex poles. 1 plus 2 into zeta 0.4 by omega n 10. Yes, plus S square by 10 square. Whole power 5. Next. So next here what happened? What is the change in slope? Opposite sign and add. opposite sign and add. So plus 120 plus 180 plus 180 plus 180 means what happened? Here no zeta means real. So divided by 20. Real means divided by 20. 20 means 9 poles. Sorry, 9 zeros. 9 zeros. Plus 9 zeros. So that means 1 plus s by 50 whole power 9. Now come on, where you know 60 at a frequency of 0.1 equal to 20 log k minus, we consider only k by s square only, na? K by s square, because 0.1 is 4 is greater than 0.1, 10 is greater than 0.1, 50 greater than 0.1, all are neglected. So simply magnitude of k by j omega whole square. The simply what I will get 60 at 0.1 equal to, what is k value here? 20 log k minus 40 log omega. Omega 0.1 plus 40. Plus 40 means come this side minus 40. So 20 equal to 20 log k equal to 10. That's all. This is the this and the Bodo plots. Next we'll start the volume 1 questions. First root locus I will complete. After root locus, solved all of you. Up to what time? Many students are asking up to 7 only class. You tell what time you want it. 7 or 9. 8 o'clock. Okay, middle will take up to 8 o'clock. Okay. 7, we don't want 7, don't want 9. Up to 8 I'll take. Okay, na? Okay. Okay. First root locus will complete, then we'll start the polar plots. Just introduction of polar plots I'll discuss, so that tomorrow we'll enter into the problems. Okay, na? Jivika.
Hello.
Matel.
Sir, in the in the complex 4 starting page number 33. So here when we find the error, then we take m actual minus m error. Yes, sir. Here m correction.
That and all we don't require. Actually,
Yes,
zero, na? What is that omega and what is the asymptotic? 0.
Oh, okay, sir.
That's why simply it is what m actual value. Okay.
Okay, sir.
Okay, first we'll complete the root locus questions. After that, we'll come to the doubts. Okay, first root locus questions. Otherwise, it will become pending. All of you solved root locus questions? All of you solved it, root locus questions? Okay, we'll solve it. First question. Listen. Root locus. Question number 1. Volume 1. So consider the points. There are given 2 points, that is S1 equal to -1 plus j root 3 and S2 equal to -3 minus j root 3. -3 minus j root 3. In the explain, they asked which points on the root locus they are asking. Simply g of s, h of s equal to angle condition, na? K by s plus 2 whole cube. S plus 2 whole cube. Now, for example, first bit S1 I will take. GH of S at S equal to S1 equal to -1 plus j root 3. that equal to k by substitute. That's all. Angle of s equal to replace -1 plus j root 3 plus 2 whole cube. Angle of k. So then angle of k by angle of 1 plus j root 3 whole power 3. Angle of k is 0 degrees divided by 3 times now. So 3 times of tan inverse of imaginary part by real part means root 3. Tan root 3 is 60. 60 into 3, 80. That means simply you'll get minus 180. So satisfies angle condition. Satisfies angle condition. Given point on root locus. Given point on root locus. Similarly, solve the second bit. You don't get, it is not on root locus. Can you do now? For S2, GH of S for S2. You can solve now S2. Minus 3 minus j root 3. So angle of k by angle of, so minus 3 minus j root 3 plus 2 whole power 3. Angle of k by what I will get? Minus 1 minus j root 3. How many times? 3 times. Angle of k is 0 degrees divided by 3 times of negative real, negative imaginary. So that means 180 plus angle. Already I told you now 180 plus tan inverse of imaginary part root 3. Real part is 1. So now get the answer. Minus 3 times of how much? Tell? 180 plus 60 means 240 degrees. So how much? I think it is not multiples of 180, I think. How much you are getting? I think 720 degrees minus 720 degrees. So 4 times of minus 180. Even multiples, not on root locus. Even multiples, na? Even multiples of 180. Not on root locus. Like this also. Next, go for second question. What is the second question? They given RLD, overdamped they are asking. See here, listen all of you. Here one pole given, like this given. Here K0, here K0, here K4. So now this range for overdamped, this is for overdamped. Already I told that means K greater than 0, less than for overdamped system. That's all. Next, question 3. Third question. Third, fourth, fifth, sixth common data question. Third, fourth, fifth, sixth common data question. GH given is K by S into S plus 1 into S plus 2. What is asked? Third question is asymptotes meet at where? Centroid. Asymptotes meet at centroid. Find centroid. That's all. Sigma equal to sum of real part of all minus 1 minus 2 0 divided by P minus Z3. That means minus 1. That is the answer. Next question 4 is what? Break point and intersection point with imaginary axis. You can do it now. You can find now. Break point means simply what? D by ds of 1 by, expand this, s cube plus 3s square plus 2s. Make equal to 0. U dash 0 minus b 3s square plus 6s plus 2 equal to 0. Now find the roots. Find the roots. So I think you will get the roots are minus 0.43, comma 1.57, minus 1.57 you will get. But which are valid means first one valid, second one invalid. Why? Because here one pole, here one pole, here one pole. Minus 2, minus 1, 0. Root locus branch exists between 0 to 1 as well as 2 to minus infinity. So minus 1.57 not on root locus, so it is invalid. Minus 0.423 is valid breakpoint. Intersection point with imaginary means RH criteria. I think we can find imaginary RH. What a characteristic equation? S cube plus 3s square plus 2s plus k. Simply this root of s power 1 coefficient only intersection point. That means plus or minus j root 2, I think, intersection point. That is the intersection point. K value means internal product equal to external product. K equal to 6. We discussed RH criteria, simple third order system. Next bit. This system is underdamped for the value of K is. That means you have to draw the root locus diagram. Underdamped means to the value of K means you have to draw the root locus diagram. So what happened? Tell here one pole, here one pole, here one pole. Here there exists the root locus. Here also exists the root locus. Breakpoint already we find. Na? That is what? Minus 0.423 breakpoint. Here K0, K0, K0. 3 asymptotes 60, 180, 300 like this. If you draw the RLD, both intersect like this. Then you have to draw like this. This is the root locus diagram. Poles will move like this. This is the root locus diagram. Here we find K equal to 6. You have to find K value at this point also. Find K value at the break point. Product of lengths, use it. What is the length from here to here? This is na 0.23 na. Yes sir, na correct na? Yes, correct. 0.43. 0.423 up to here to here. This is minus 1, this is minus 2 na. If it is 0.43 up to this 0.423, what is the distance? 1 minus this na. That is 0.577. And distance from here to here is 1.577. You solve this, the K is nothing but here. You will get 0.384. Now when it is underdamped, tell this total range is underdamped. This total range is underdamped. This total range is underdamped. Underdamped. Here how much? 0.384. Here how much? 6. That means K is greater than 0.384. Less than 6. System is underdamped. K equal to 6 undamped. 0 to 0.346 overdamped. That's all. Next, sixth question what? Sixth question is range of K for non-oscillatory. Sixth question, non-oscillatory. Non-oscillatory systems you tell, come on. What are the non-oscillatory systems? Anybody? Non-oscillatory systems, anybody? Non-oscillatory systems. Critical and overdamped. Critical and overdamped systems are non-oscillatory. Critical and overdamped. The K is what? Greater than 0, because 0 means marginal stable. Greater than 0. This total is non-oscillatory. Greater than 0, less than or equal to 0.384. 0.384. Less than or equal to 0.384. That is called a non-oscillatory. Okay, na? Even equality can put equal to also non-oscillatory only, but it is not stable. It is not stable. Just like step response, you will get it. Okay. Next. Next question. Seventh one. Seventh one, what they are asking? Open loop transfer function of system, complex roots, center and radius. Just find the breakpoints. Na? You can find the breakpoints. Na? K into s plus 3 by s into s plus 2. Find just breakpoints. Okay, d by ds of, I hope you can do by yourself, s square plus 2s equal to 0. Then solve it. What I will get? 1 into s square plus 2s minus s plus 3 into 2s plus 2 equal to 0. Now solve this equation. We solve it and find the breakpoints. I think you will get the breakpoints is minus 1.27 comma minus 4.73 will get. What I told, center is nothing but midpoint of breakpoint. Remember, center is midpoint. That means minus 1.27 minus 4.73 divided by 2 is the center. So that means how much? Minus 3 center. Center is minus 3 comma 0. Radius is distance from center to any breakpoint. And minus 3 to, for example, 4.73. What is the distance? R. That is called R. That means 1.73 is the radius. So that is called root 3. Next, 8th question. We'll complete. 8th question. 8th question is the open loop transfer function given. So GH equal to K into S plus same transfer function. Value of K at S equal to minus 4. At minus 4 value they are asking. Here 0. Here minus 2. Here minus 3. At minus 4. What is the K value they are asking? Product of lengths, use it. Here to here, what is the length? Here to pole, 4 units, 4. Here to this pole, 2 units divided by 2. Here to here, what is the distance? 1 unit. Product of lengths from point to pole. Point to pole, how much? Here to here, 4. Here to here, 2. Here to here, 1. So that means K equal to 8. K equal to 8. Next, 9th question. Angle of arrival. Angle of arrival they are asking. You can solve now. Angle of arrival. So angle GH equal to. So what is the location? They given already, location also given. S equal to what? 2 plus J2 given. Plus R minus given at plus 2 find then enough. So angle of K, roots if you write, angle of S square minus 4S, S square minus 4S plus 8, S square, next plus 4S plus 8. This can be written as angle of K, angle of, I think S plus 2, S minus 2. S minus 2 minus J2, angle of S minus 2 plus J2 divided by angle of S plus 2 minus J2, S plus 2 plus J2. Now substitute S equal to 2 plus J2 and solve it now. You can solve angle of K, 2 plus J2 means it becomes 0. 2 plus J2 means it will become J4. Here 2 plus J2 means 4. Substitute it, just this value substitute. 2 plus J4 means 4 plus J4. I think 0 plus 90, 0 plus angle of 4 also 0. So 45 degrees. So then angle is 90 minus 45. Then it becomes 45 degrees. What is the angle of arrival formula? Phi A is 180 minus angle GH. So 180 minus 45. So how much? 130 plus 135 degrees. So finally pi A is plus R minus 135 degrees. Like this you have to solve. Next, 10th question. Angle of departure. Do by yourself. Same steps, na? Plus or minus 45 will get. Angle of departure. Same procedure. Plus or minus 45 degrees. Breakaway point from the root locus real axis. That also do by yourself. And I easily can do now. 11th question. Directly you can identify because it is not a point where the breakaway is there between 2 to 5. Na? Between 2 to 5 breakaway point is there because here one pole, here one pole, here 1 0. So here breakaway point. Actually, 2 breakaway points are there. Here also is there. Here also like this is there. But they given option is like this actually. This is the diagram actually. Here also this is breakaway. Here also breakaway actually. So if both are there, you have to select. But here both are not there, na. Only what is given between minus 10 to minus infinity is there, or at minus infinity is there. Between 2 and origin is there. Minus 2 and minus 5 is correct. Answer D correct. The answer. This is breakaway point. 10th one, draw the root locus by yourself. Okay. Now doubts. If you have any doubt, you can ask. Come on. Samata. Samata. So we'll close by 7. Huh? Samata. Akans.
Hello?
Tell.
So page 29.
Page
29.
29. Tell.
Sir, here while calculating K means in the last you have written 10 is equal to 20 log K. There we have not considered that pole on origin 1.
Where pole at origin? That is given in the question. Why you are thinking that?
So for calculating magnitude we are using, you told always to
shift. We are doing here not calculating magnitude. We are doing the shifting.
Yes, sir.
We are doing shifting. How much shift we are doing, that you have to observe.
Yes, sir. For shifting itself, you wrote now the magnitude to plot shift downwards by minus 10 dB. And
no, that's all. No, minus 10. Shift is depends on K value only, na.
Okay.
That's why we'll write shift equal to 20 lakh K. Na, I told na shift equal to 20 lakh K. Here, how much down you are shifting? Minus 10. Minus 10 equal to 20 lakh K.
So this magnitude shift is equal to 20 log K. We are getting from that formula itself.
Yes.
20
shift
log
equal to
K.
20 lakh K. That's all.
So,
downward shifting minus 10. Downwards means negative sign. Shifting upward means positive.
Yes, sir, that I understood. Just I thought that while calculating earlier, we were calculating magnitude and utilizing that.
We are not calculating any
Yes.
magnitude here. We are shifting the plot. That's all.
Okay, then we have to just consider K and ignore all the other poles.
That's all.
Okay, and so now when you were solving root locus questions, then one question was asked for angle of departure. And other angle of arrival. So when you were teaching, then you said that angle means both will be same. For what
when change the poles and zeros, is there change poles and zeros location there?
Okay, means in place of poles, if there are 0, then?
If 0 comes pole, poles comes 0, then it will be same.
Okay,
Is it changed there?
No, sir. Okay.
Normal then?
Got it. Thank you, sir.
Next, Arsha.
Hello, sir.
Tell me.
Sir, in 39 page number.
39. Tell.
Sir, here from minus, actually it is minus 10, sir.
This is minus 10.
11th question. But here minus 10 to minus infinity also there is a one break point. No, sir.
But I told na first priority is what? When comes from local author book, what I told? Living the real axis, na?
Yes, sir. Okay. If two options are there, we should take
then
local.
we can go for that.
Okay, sir. Sir, and in 37F, sir. Sir, this fifth problem I couldn't understand, sir.
I told na underdamped, critical damped, overdamped. Which one you didn't understand?
This one actually K value. How
K
we
value, product of length. Year to year, what is the length? This is point minus 0.23 na?
Yes, sir.
0.423 and this length is 0.423 only na?
Yes, sir.
And this length 0.577 na?
Yes, sir.
This is minus 1. This length 1.577.
1.5.
That 3 product, then you will get the K.
Okay, sir.
Okay na?
Okay, sir. Got it, sir. Thank you, sir.
Next, Arsha.
Hello.
Tell.
Sir, page 30F, sir.
30F.
3, sir. 30.
Okay.
Sir, once explain this one, sir. I understood gain margin, but I didn't understand phase margin, sir.
At minus 160, what is required? Tell.
Gain.
At minus 160, what is the need?
Phase margin of 20 degrees, sir.
Minus 160 degrees, what is required? I have omega GC.
That's the gain crossover frequency.
At minus 160, we required omega GC. Here
Yes,
we
sir.
required omega GC. But that means how much up we have to shift the plot?
Plus 10 dB.
That's all.
Okay, sir.
Next, Naveen. Naveen.
Sir, volume 1 second question, sir.
Tell. Page number. This one. Tell.
Sir, here pole value is not given, no, sir. How will I identify, sir?
Pole value, why we required? We can identify easily pole value. This is 4 na? This is 0 na? Yes or no? This should be minus 4 na? Yes or no? This length, this is K4 na? K4 means 2 into 2 kada ya? 4 can be written as what? Hello? 2 into 2.
Origin.
K4 means it is 2 into 2. 2 into 2 means this distance is 2, this distance is 2. So here minus 2, this is minus 4. GH becomes the what? K by S into S plus 4.
Okay.
Next, Abdul.
హలో
Tell.
సార్ సార్ మనకి ఇప్పుడు ఈ ప్రాబ్లంలో నెక్స్ట్ ప్రాబ్లం ఉంది సార్. అది ఇందాక సార్ ఇప్పుడు అన్ని ఫిఫ్త్ది ఇప్పుడు అండర్ డ్యామ్ కండిషన్ ఒక ప్రాబ్లమ్ లో అది నేను ఏమనుకున్నా అంటే గ్రేటర్ దెన్ 0 ఫిఫ్త్.
What is the direction? This is the direction na? So here to here it is under damped.
ఓవర్ డ్యామ్ కి ఇటు సైడ్ ఉంటుంది కదా.
Over damped 0 to here. This is over damped. 0 to here is over damped.
ఓకే. క్రిటికల్లీ డ్యామ్ అంటే
Exactly equal.
ఓకే.
Okay na? Naganitesh.
Good evening, sir.
Good evening.
Sir, 10F page.
10?
F, sir.
Tell.
అదే సార్ సార్ ఇక్కడ మనం డైరెక్ట్ ఎందుకు చేయలేమా సార్? ఎందుకు చేయలేము సార్?
We do this like this na, directly. We know shortcut na.
అంటే జస్ట్ లైక్ అప్పుడు రీజన్ చెప్పారు కదా సార్, అదే అర్థం కాలేదు, జస్ట్ అందుకని.
What is here? We don't know anywhere. We don't know any at any frequency. Do you know magnitude here? Here we don't know magnitude. Here we don't know magnitude. Here we don't know magnitude. Then how can you find K?
Sir, atne.
If you remember this, then only we can find the K value.
Okay, sir. Sir, log omega K positive values తీసుకోవద్దన్నారు కదా సార్?
Positive values by mistake. Generally, log omega given, there will be negative and positive values. Log omega given means negative and positive value. For example, here all positive gives. For example, here log omega gives. What happened? Tell. Log omega equal to 10. Omega equal to how much? 10 power 10. That much frequency they'll take.
No, sir.
That's why. So whenever log omega and all the positive values are given, you observe the options.
Okay, sir.
Here corner frequency the transfer function corner frequencies are same means, then that log is by printing mistake. That's all.
Okay, sir.
Okay, na?
Okay, sir.
That's all. Any more doubts? No more. Now tell either continue or close. Right. Akans, tell Delhi.
Hello?
Tell.
Yes, sir. That GM gain margin question shift one. There was one plus 10.
Tell.
Sir, and the magnitude given was minus 20. Then by shifting plus 10.
Shift you have to observe. Why you are observing the magnitude, you tell for first of all.
No, sir. I am observing shift itself.
That's all.
Sir, yes, sir, this question.
This one, tell.
Yes, sir. Here if we will shift by 10 upward, then omega GC should coincide with omega PC. Right?
Why is it marginal stable? Plus 10 dB means it will become marginal stable? No. Why is it becomes omega PC equal to omega GC? It never becomes.
Okay. Yes, sir.
Okay?
Yes, sir. Yes.
Right. Continue or close? Decide by yourself. I'll see majority polling, then I'll decide. Close it. Most of them are close. Okay. Okay, good, good. Sir, I will close it. Some people continue, close. By Friday, we'll close the syllabus, whatever it is. Or we'll continue another 10-15 minutes. Now time is what? New chapter, na? Why unnecessary? So I'll complete by Friday, no need to worry. But today you try to solve all the questions in border plots so that you'll become more confident. Volume 1 questions you solve in the border plots. Okay? Okay, na? So any doubts there you can raise the hand. No doubts? Okay, I'll close it. Sorry for the scolding. Okay. Because repeatedly same thing asking, I scold you. Okay. Okay, Amma. I'll close it. Okay. Venkatesh, what is the doubt?
సార్ అది బ్లాక్ డయాగ్రామ్ లో ఒక డౌట్ ఉన్నా సార్. అంటే సార్ ఒక క్వశ్చన్ ఉంది సార్. ఇప్పుడు R1 R2 C1 C2 అంటే C1 C2 ఉన్నాయి సార్. రెండు ఇన్పుట్లు రెండు అవుట్పుట్లు ఉన్నాయి సార్. అది బ్లాక్ డయాగ్రామ్ ఉంది సార్. అది C1 by C2 కనుక్కోవాలంటే C1 by R1 C1 ఏదో ఒకటి కనుక్కోవచ్చు కదా సార్.
ఏం కనుక్కున్నాడు? C1 కనుక్కున్నాడా? What is
C1 by C2?
C1 you have to find or R1 C2 you have to C1 by R1 you have to find.
C1 by C2 కనుక్కోవాలి సార్.
C1 by C2 they don't ask. They'll ask either C1 or R1. You tell the page number. Volume 1 or volume 2?
సార్ అది సెమిస్టర్ ఎగ్జామ్ కి వచ్చింది సార్.
C1 by C2 na. C1 and total C1 you have to find. C1 due to R1, C1 due to R2 you have to find. Then both should be added. Again okay, C2 by R1 you have to find, C2 by R2 you have to find. Then both should be added. Then that will become C2.
Okay, sir.
Okay, na?
Okay, sir.
Okay.
Other than
tell man.
ఆ తర్వాత దాన్ని మొత్తం C1 C2 వచ్చిన తర్వాత C1 by C2 చేయాలా సార్?
అంతే, C1 by C2 చేయాలి అంతే.
ఓకే సార్.
ఓకే అమ్మా. So I'll close here. Don't worry, I'll close the syllabus by Friday maximum. Okay, na? Okay.